Hello out there, you are welcome to DaveTuts Academy, where we are devoted to building excellence in STEM education. Today's video is going to be so wonderful because you are going to be learning quite a whole lot of things. So first, you need to identify that are you preparing for any O-level exams? Talk about WAEC, NECO, GCE, GED, GCSE, any grade 12 exam at all. Now, this is going to prove very useful for you because the topics that you are going to be facing in your exams are judiciously treated, they are well explained, they are demystified for you to gain that academic excellence that you are looking for in your exam. So we want you to just get set, get your pen, get your biro. I always say that you don't get excellence just by watching these videos, you get excellence by getting your hands dirty. So take that biro, take that worksheet, take that book, take that calculator, let's walk along so that we can actually build this proficiency in you. Some of the things we are going to be covering include set theory. We are going to be looking at algebra processes, circle theorems, trigonometry, measuration of plane shapes, statistics, probability. We are going to be looking at constructing trigonometric graph. We are going to be looking at word problems in mathematics. We are going to be looking at ratios and proportions, sequences and series. We are going to be looking at bearings and distances featuring word problem. We are going to be looking at the cumulative frequency curve, popularly called Ogive. We will be looking at circle theorems, circle geometry. We'll be looking at areas and volumes. We'll be looking at construction. That's an area that I know students run away from so much. And we'll be looking at how to solve quadratic equations with completing the square. So these are just jam-packed for you, and we don't want you to miss out so that you can actually be prepared to gain that academic excellence that you have always been longing for. Now, we just want to crave your indulgence to go ahead and subscribe to our channel. See, there's so much effort that are involved in creating these videos out of our busy schedule. To take time out, work on this, prepare the questions, prepare the solutions, do the voiceover, edit the videos. It takes weeks and weeks to get this into production, and you can see a video like this that's even like 4 hours, and it's actually a whole lot of effort. Now, we don't just want to put this out there without getting feedback from you. So as you are watching this video, we want you to leave your comments for us to actually get feedback on. We want to know what are the things we are doing right, what are the things we are doing wrong, what are the things that you think we can improve upon, what are the things that you desire that we need to help you with. See, that's why we are putting our effort to contribute our quota to building excellence in students so that their desired aim, their desired goal, a better tomorrow that they are longing for, they are going to get. So please just leave that feedback for us. And if you are here to subscribe, I wonder what you have been waiting for. We have quite a whole lot of videos, resources that are geared towards preparing you for excellence, especially for your STEM education. So our playlists are just devoted to handling so many topics that students normally find problematic, having difficulty. We just go through them, and you are going to see that these are actually making things easy for you because we want to build that excellence with you. So just take it, it's free of charge. Just go ahead, click on the subscription icon, click on the notification bell so that you get information on our videos immediately we actually upload them, and then you can comment on the video like we said before, click on the like button, and let's know that yes, what we are doing is making a whole lot of effort. So without much ado, let's head over to our video for today. We have this question here on set theories, and we are told that if A is defined as a set of multiples of 2, and B is defined as a set of multiples of 3, and C is defined as a set of factors of 6, all these, they are subsets of the universal set that is defined as x in the case in which 1 is less than or equal to x, which is less than or equal to 10. We are to find A complement intersect B complement intersect C complement. So you have seen how to make the statement for this particular question. In order for us to solve this effectively, we need to first define our universal set, because every other thing are going to be subset. They are going to come under that universal set. So to start, we can just say we want to define our universal set to be, we are told that x, where x is from the range 1 to 10, so we need to define it. Here, look at what they are saying. They said 1 is less than or equal to. Because of the or equal to, we need to include 1, okay? So we just have incremental values 1, 2, 3, 4, 5, 6, 7, 8, 9, and also because we have x to be less than or equal to, because of the or equal to, 10 will be inclusive. I didn't mean that it's just less than 10, then we would have stopped at 9. Okay, so this is our universal set. Then we can go ahead to define all that we are given. Like in the first case, A were given to be the multiples of 2. So looking at this particular universal set, what are the multiples of 2 that we can have here? We can have 2 multiplied by 1 is 2, multiplied by 2 is 4, multiplied by 3 is 6, multiplied by 4 is 8, and then multiplied by 5, that is 10. So that is the set that contains the elements of A. And then B, we have to look at B. B is the set that is defining the multiples of 3. So we have 3 multiplied by 1 is 3, multiplied by 2 is 6, multiplied by 3 is 9. Any other value will go beyond the scale of our universal set, okay? And then C is the set that is defined as the factors of 6. So what are the factors of 6? We know we can have 1 times 6 to give us 6, okay? We can have 2 times 3 to give us 6. Then again, we can have 3 times 2 is still 6, and then 6 times 1. But you can see these are just repetitive value of this particular 2. So it will suffice for us to just pick the first 2. And just if we are to arrange them sequentially, so you can say we have 1, 2, 3, and 6, in which 1 times 6 or 6 times 1 are factors of 6. 2 times 3 or 3 times 2 are also factors of 6. Okay, so we've been able to define our set as we are asked to do. Now, look at what we are asked to find. We're asked to find the intersect of A complement, intersect B complement, intersect C complement. So it's the set that is defining A complement, intersect B complement, intersect C complement. But we have not gotten A complement, B complement, and C complement. We only got A, B, and C. So our next task would be to just define, okay, yeah, I'm coming to A complement. And what do we mean by A complement? We need to define the set of values that are in the universal set, but they are not in A. These are the ones that are in A, but the ones that are in the universal set and are not in A, that is the complement of A. And that's how we notch it A complement. So if we look at the universal set and A, 1 is in the universal set, is not in A, so we have 1 here, okay? But we have 2 in universal set and 2 in A, that's not going to go. We have 3 in universal set, is not in A, so we have 3. In short, since A are multiples of 2, all other numbers that are not multiples of 2, we should put them now. And now we're talking about odd numbers in that case. So 1, 3, 5, 7, and 9, they are the set of values that will constitute the complement of A. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so for B, we can just say we are looking for the complement of B also, and here we have elements in B to be only 3, 6, 9. So every other number we have to just include them. So we have 1, 2, 3 is here already, we don't use that. 4, 5, 6 is here already, we don't use that. 7, 8, 9 is here already, we don't use that, and 10. Okay, so that's the set of values for B complement. And finally, C complement, we are going to define C complement, and here we have C as 1, 2, 3, 6. So just like we've been doing, this will now be 1, 2, 3 are there already, so we can start this from 4, 5, 6 is here, so we can't put 6 again. We have 7, 8, 9, and 10. Wow, interesting. So looking at what we are asked to find, we are asked to find the intercept of these 3 sets now. The A complement, intersect B complement, intersect C complement. We need to look at the elements, okay, that are common to the 3 of them. That's why we're intersecting the 3 of them. And so we can just look here. In the first case, we have 1. In the second case, we have 1, but it's not in the third case. So that is not going to be the answer, okay? In A complement, we have 3. In B complement, we don't have 3. Definitely, that's not going to be it. In A complement, we have 5. Good. In B complement, we have 5. Good. In C complement, we also have 5. So 5 is actually common to these 3, and so that qualifies. In the same way, look at 7. We also have 7 in A complement, 7 in B complement, and 7 in C complement. So we can also take 7, okay, and then we have 9 in A complement, but there's no 9 in B complement. We have 8 in B complement, there is no 8 in A complement, so those are not going to satisfy the condition that we're looking for. So holistically, we can just say, after having done this, the set that is defined as A complement intersect B complement intersect C complement is going to be the set in which the elements are containing only 5 and 7. And with this, we've been able to solve this question on set theory. We just need to understand how to interpret the sets that are defined for us, and then look for the complement and look at the common factors, and we'll get our answer as 5, 7. Alright. So in this question on commercial mathematics, we are told that tickets for a movie premiere cost $18.50 each, while the bulk purchase price for 5 tickets is $80. So if 4 gentlemen decide to get a 5th person to join them so that they can share the bulk purchase price equally, how much would each person save? So I love the fact that these gentlemen are trying to cut costs. So originally, if they had gone ahead to buy individually, so the total individual purchase would have taken them, individual purchase is going to be $18.50 times 5, okay? So, and that is going to amount to 18.5 times 5, that is 92.5. So this is going to be $92.5, but the bulk purchase cost, the bulk purchase, as we are told in the question, costs a total of $80. So the savings would have been, for the 5 of them, okay, that's good. The savings for the 5 would have been this $92.50 minus the $80 that they have the option to procure it from, and that will be $12.50. That's the savings for the 5, okay? So the savings for each one of them will be this savings for the 5 divided by 5, since they are sharing it equally. So the savings per person will just be this particular $12.50 divided by 5, because now this is for the 5 of them. For each person, we just need to divide it, and we want to do that. 5 in 12, that is 2, and 5 times 2 is 10. So 12 minus 10 is 2. So we have point here. 5 in 25 will just give us 5, and we have the 0. So $2.50 would have been the amount that each person of them, each one of these gentlemen would have saved by buying in bulk instead of going to buy individually. So teamwork is good. Let's team up. Here in this question on change of subject of formula, we're told that given that P is equal to RK over Q minus MS, all in brackets raised to power 2 over 3, we have to make Q, this Q, we have to make it the subject of the relation, and then find correct to 2 decimal places the value of Q when P is equal to 3, M is 15, S is 0.2, K is 4, and R is equal to 10. So we have our question drawn out for us, and what we're asked to do is just to change the relation and append Q as the relation which it will be standing alone on one side, and then the other will be on the other side, and we can now solve for that value of Q when we have the values of every other variables that were given in the equation. So what we are given was that P is equal to RK over Q, okay, minus MS all raised to power 2 over 3. What we need to do first is that we should just multiply both sides by 3 over 2. We are doing that so that we can knock off this power that is actually Burnley Q and then that power will be reflecting here, but then we'll be able to isolate Q and solve for it to make it the subject of the relation. And for me to do that, just see what I'm going to do here. If I have my P here, and then I'm multiplying both sides by 3 over 2, then I will just say the right hand side multiplied by 3 over 2, the left hand side multiplied by, it's as if we're having P here is P raised to power 1, okay, then multiply by 3 over 2. Now this is what is going to happen. This 3 will cancel this 3, and this 2 will cut out this 2. Then here we only have P raised to power 3 over 2, and then on the right hand side we only have RK over Q minus MS. Okay, and then for us to further evaluate this, we want Q to be on the side that we can actually relate with, so we can move MS to the other side, and once we do that, this negative sign will become a positive side, so we'll have something like this: P raised to power 3 over 2 plus MS is equal to RK over Q. Now on the left hand side, it's as if we're having all of this over 1, okay, and then on the right side we have RK over Q. For us to solve that, we can actually cross multiply so that Q we can bring to stand on its own, and if we are to do that, we now have Q is multiplying the whole of P raised to power 3 over 2 plus MS is equal to RK, because here 1 is multiplying RK to give us RK, Q is multiplying the whole of this to give us the whole of this. And once we have this and we want to isolate Q, we can divide both sides by the expression in brackets that is multiplying P. So I can say this over P raised to power 3 over 2 plus MS is also equal to RK over the same expression, P raised to power 3 over 2 plus MS. Why am I doing this? Because I want to isolate Q to be alone, and you can see here this whole expression is cutting out this whole expression, and Q that I'm looking for, that we're asked to make the subject of the relation, will be RK divided by P raised to power 3 over 2 plus MS. The critical steps that we took was that starting from the onset, we multiply by the inverse of the power that we have here. So we have 2 over 3 as a power, and we multiply by 3 over 2, which is the inverse of that power, so that we can free up the right hand side from its power. And we are doing that because Q is included in that. Okay, so from there we just solve algebraically to arrive at the answer that Q is equal to RK over P raised to power 3 over 2 plus MS. This is the solution to the first question that we're asked to solve, that we should make Q the subject of the relation. So we'll now go ahead to try and solve for the second one. So now to solve for the second part of our question, already we have found Q to be RK over P raised to power 3 over 2 plus MS. But look at what we are given. We are not given that P, each of all these values are appended for us. P is 3, M is 15, S is 0.2, okay, K is 4, and R is 10. So this is just as simple as it can get. We just need to put all of these values, we need to put them into this particular equation to say that we have Q is equal to, what's the value for R? That is 10. What's the value of K? That is 4. So we have 10 times 4 divided by, what's the value for P? P is 3. So we have this to be 3 raised to power 3 over 2. Okay. Plus, what's the value for M? M is 15. Then what's the value for S? That is 0.2. Now we need to be careful because we need to bring into our operation the technique of BODMAS or PEMDAS, whichever one you want to call it. That means we should solve the ones in bracket first. On the numerator, we have 10 times 4, that is 40 over 3 raised to power 3 over 2. plus 15 times 0.2, that's if you're having 15 times 2, that is 30. But then the decimal place, which is only 1, will come to affect our 30, and that will give it only 3. Okay, so what we need to actually evaluate now is what this value is going to give us. 40 over, what is 3 raised to power 3 over 2? We can bring in our calculator to say we want to find 3 to the power of 3 over 2. Okay, that's 5.1962. okay, because this 5 I can round up to 1 and add to this one. 5.1962 5.1962 plus 3. Okay, so this will be 40 over 5.1962 plus 3 is 8.1962, and that is equal to, so I have, okay, my answer plus 3 is equal to 8.1962. Then 40 divided by that answer, which is my denominator. So I have this as 4.88033. But looking at the question, we are even told to find correct to 2 decimal places. And looking at the calculator, we are seeing that 4.88 and 0 is coming next. Then 0 will not have any effect. So our final answer will be 4.88 because that is in 2 decimal places already. So I can just write this as being approximately equal to 4.88, and that is the solution to this particular question. In this question on ratio, we are given that x plus 2y over 5 is equal to x minus 2y, and we are to find the value of x ratio y. Okay, good. In this question, we can just write out the equation that we are given, that we have x plus 2y over 5 is equal to, here we have x minus 2y. A number divided by 1 is still that number, so I can write this as over 1, and then I can cross multiply, because the aim of what I want to do is to simplify this to its barest minimum and then try to find the ratio x over y from the resulting solution. So here, x plus 2y multiplied by 1 will still remain x plus 2y, okay, equal to 5 multiplied by the whole of x minus 2y. Okay, so if I want to open this bracket, I can see this to be x plus 2y is equal to 5 times x is 5x, okay, minus 5 times 2y is 10y, and then I can collect like terms. And looking at this, if I want to take 5x to the left hand side, okay, let me just do that. I will have x minus 5x is equal to, here I have minus 10y, and then when 2y moves to the right hand side, it becomes minus 2y. So I will have x minus 5x is minus 4x is equal to minus 10y minus 2y is minus 12y. Now look at this, or let me just knock out the negative sign first, or just better still, what we want to find is x ratio y, that is like x over y. So I want to divide both sides by y, okay? So I'm saying this is over y, but what I do to the left hand side, I also do to the right hand side, okay? That's the first thing I want to do. Then again, look at this. I want it to be just x over y, but still coefficient of x, which is minus 4, is still remaining here, which is hindering me. So I should also divide by minus 4 and minus 4. So what I'm actually using to divide is minus 4y. So on the left hand side, I can say here I have minus 4 here, can cut minus 4 here. So I will have x over y remaining here. Then here, minus 4 can go in minus 12 in 3 places. Here it can go 1, here it can go 3. So what I'm going to have eventually is that I will have it to be x over y is equal to 3 over 1, because also look at this. This y has also cut out this y. So I've eliminated y and on the right hand side, and I've eliminated minus 4 on the left hand side. What you just need to note, student, you don't need to be confused with this. What you just need to note here is that what we have is we have minus 4x and here we have minus 12y. First, divide both sides by minus 4 to knock out the minus 4 that is the coefficient of x. And then, because we want it to reflect x over y, then also divide both sides by y. So, on the left hand side, you can see here we have x over y. And on the right hand side, the negative numbers will cut out each other to give us 3 over 1. Meaning that eventually what we're asked to find, that the value of x ratio y is going to give us 3 ratio 1. And that is the solution to this problem. Here in this question on circle theorems, we're told that in the diagram, O, this O, is the center of the circle ABCDE. Then line BC is equal to line CD, and angle BCD, this angle here, is equal to 108 degrees. We are to find angle CDE. So if you want to identify that, you can just go ahead to say this angle here is the angle CDE that we're asked to find. You can see starting from CD and ending at E. That's the angle we're asked to find. So how do we go about solving this type of question? What we need to bring to mind is our understanding of all the circle theorems that we can employ to try and solve this question. And for me, first and foremost, I'm looking at this question. It's in the compulsory part of the exam paper, and I know that generally questions there are not expected to be as difficult as questions in the other section B. And then look at this. This is even question 3A. Then this should be a simplified work. There are so many theorems I could have tried hacking my head into trying to solve. For example, I know that from the diagram, if I take BD as 2 points that I can actually consider taking angles off the circumference from, like I can have BAD, I can have BED. Those two angles are going to be the same. So the angle here, I know we also equal to the angle here, okay? Because they are angles in the same segment of the circle. And this is the chord. If I draw a line from B to D, just like this, so I know that is obtainable, and angle BAD is equal to angle BED. But because this is just a simplified diagram, do I really need that? I don't think I do. Because if I look at this particular triangle BCD, from the triangle BCD, there's something I can note, because in the question we are told that line BC is equal to line CD. So BC here and CD, they are equal. So the triangle BCD is actually an isosceles triangle. So for an isosceles triangle, the property we know is that the base angles are equal. So if I render this as, let me say this is X, at B here, if I have this as X, then this angle here is also equal to X. And why? It's because they are the base angles of isosceles triangle. So I can say from triangle BCD, angle CBD is equal to angle CDB, and that is X. You can see CBD and CDB, each of those angles is X, and they are equal because they are the base angles of isosceles triangle. So my understanding of an isosceles triangle had helped me to actually postulate that theory, and since I know that, I can now go ahead to add up the sum of the angles of that particular triangle. So from the same triangle BCD, I can say the 108 degrees that we are given plus X, which is the angle here, plus the other X, they are going to sum up to 180 degrees because they are the sum of angles of a triangle. So if they are the sum of angles of a triangle, they normally will sum up to 180 degrees, and then I can just say that implies that 2x is equal to 180 minus 108. So 2x in that case is equal to 72, and if I divide both sides by 2, I can just see that here 2 here will cut this to 2 here 1, 2 in 7 is 3, remaining 1, 2 in 12 is 6. Therefore, angle X can obtain to be 36 degrees. So this X is 36 degrees. But Another thing I can also note from the diagram is that, look at this, we were told that O here is the center of the circle. So the line BOE happens to be the diameter of the circle. You can see it's starting from one end of the circumference, passing through the center of the circle, and ending at the direct opposite end of the circle at the circumference. So this is actually the diameter, and if that is the diameter, then the angle BDE, this angle here, I want to indicate this in blue. This is going to be a right angle because it is the angle subtended by the diameter of the circle at the circumference. So this is because it's angle subtended by diameter at the circumference of the circle. Okay, so knowing that this is 90, and initially I can see that the angle that we're asked to look for originally is from this point at C to that inclination at E, and you can see this particular angle is incorporating the two angles that we just evaluated. First, it is x plus 90, so I can say that the angle CDE that we are asked to find from the diagram is equal to angle BDE that we just evaluated to be 90 plus the angle X, which is CDB. Those are the two angles that constitute that angle we are asked to find. So if we are to evaluate that, BDE is 90 and CDB is X, which is 36. So 90 plus 36, that's going to give us 126 degrees. And with that, we can just see that our solution to the question is out and our answer is 126 degrees. What did we make use of? It is our understanding of the fact that the base angles of isosceles triangle, they are equal, and that's why from triangle BCD we can get X, and then if we sum all the angles of a triangle, they add up to 180 degrees, which will help us to evaluate X to be 36 degrees. And then looking at the diameter of the circle BOE, we know that the angle subtended at the circumference by the diameter is a right angle. That's one of the postulates of the circle theorems. And then CDE, which we are asked to find, is the sum of BDE and CDB. So if we add those two, we got our final answer to be 126 degrees. If you want more questions on circle theorem, circle geometry, just go ahead and check our playlist. We have quite a lot of videos, particularly on circle theorems, that you can use to build your proficiency in solving questions like this. All right. In this question on trigonometry identities, we are told that given that tan x is equal to root 3 and the value of x is ranging from 0 to 90, so meaning that x is an acute angle, at most it is a right angle, okay? Then we are to evaluate cos x raised to power 2 minus sin x over sin x raised to power 2 plus cos x. So there are actually two ideal ways that you can go about trying to solve this. Is in the first case, you can say you bring your calculator and you are saying that we want to evaluate the arctan of root 3. Like already we are given in the question that tan x is equal to root 3. Then we can say x is going to be arctan root 3, and that's going to give us a particular value that we can evaluate from the calculator, that we want to evaluate arctan square root of 3, and then you want to close the brackets, so that is 60, and that is 60 degrees. And you can see 60 degrees is actually between this range of values that were defined for x. So you can now say you want to get cos x raised to power 2 minus sin x over sin raised to power 2 plus. But I'm not going to be doing that. I'm going to be giving us a pictorial view of our triangle. And for us to be talking about these values like this, perhaps we can actually look at the diagram as if it's a right angle. Okay, let's say you have a right angle triangle here, and in this particular triangle we can take one of the angles to depict x, And then we know that tan x from SOHCAHTOA, we want to look at SOHCAHTOA, which is telling us that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. Tan x will be the opposite side facing x over the adjacent. And look at this. We are told that it is root 3. So we can say this is synonymous to root 3 over 1. So that means from there, we have our opposite to be 3. The opposite is not 3, is root 3. Okay. The adjacent is 1. Then we need to find the hypotenuse. So if we want to find the hypotenuse, we can say, looking for the hypotenuse, we can make use of the trigonometry identity. Here we have this to be root 3, which is the opposite, the adjacent to be 1. So what's going to be the value of this? That hypotenuse, the square of it, call it h raised to the power 2 is actually equals to root 3 raised to the power 2 plus 1 raised to the power 2. So h raised to the power 2 will be root 3 raised to the power 2. The power 2 and root will cancel out, so we have that as 1. Then 1 raised to the power 2 is 1. So h raised to the power 2 is 4, and h itself will be square root of 4, which is 2. We don't need to be talking about plus or minus 2 here, because on the measurement scale, we will not have it as negative 2. So the hypotenuse here is 2. So I just took the pain to express that. We really don't have need of that, because this is actually as plain as you can get. If tan x is root 3, then you have the adjacent to be 1, the hypotenuse to be 2, and the opposite to be root 3. So now for us to evaluate this particular question, we want to look at cos x raised to the power 2 minus sin x divided by sin x raised to the power 2 plus cos x. So we need to actually find cos x sin x for us to be able to use this. And from what we have defined before, sine is opposite over hypotenuse. So in this particular case, sin x will be, what's the opposite? It's still root 3, okay, over what's the hypotenuse? That is 2. Then cos x will be, the cos is adjacent over hypotenuse. What's the adjacent? That is 1. And what's the hypotenuse? That is 2. So that's what we need to input into this particular equation that we are trying to solve. And for us to do that, we are going to have it that, cos x we have gotten to be 1 over 2. So we have 1 over 2 raised to the power 2, okay, minus sin s is root 3 over 2, okay, divided by sin s again, that's root 3 over 2, all raised to the power 2, plus cos x is 1 over 2. So this is what we just need to solve. 1 over 2 raised to the power 2 is 1 over 4 minus root 3 over 2 divided by root 3 over 2 raised to the power 2. If we take it fraction wise, at the numerator, root 3 raised to the power 2 will be 3 as explained initially here. Then over 2 raised to the power 2 is 4 plus 1 over 2. So if we want to solve this, for the numerator, we can find the LCM to be 4. And here, 4 divided by 4 is 1. 1 times 1 here will be 1, okay. Then this negative sign minus 4 divided by 2 is 2. 2 times root 3 will be 2 root 3, okay. Over here, we also have 4 as the denominator. Then 4 divided by 4 is 1. 1 times 3, that is 3. Plus 4 divided by 2 is 2. 2 times 1, that is 2. So if we are actually to solve this, that means we are going to have, at the numerator, we have 1 minus 2 root 3 over 4, okay, divided by 3 plus 2 is 5 over 4. So if we are to actually solve that, this will become multiplied by 4 over 5. Okay, so I just want to do that because I'm running out of space now. So this will be times 4 over 5. So we can see that 4 at the denominator here and 4 at the numerator here they will cancel out such that our answer will be 1 minus 2 root 3 over 5. So this is going to be the solution to this question. And like I said before, you could have said that you want to evaluate x to be 60 degrees, then you find sine 60 raised to the power 2 minus sine 60. So you find cos 60 raised to the power 2 minus sine 60 over sine 60 raised to the power 2 plus cos 60. But all the same, you still arrive at this. But this is the ideal way that you are actually expected to solve this question. And if you do it right, your final answer will be 1 minus 2 root 3 over 5. This is a question on mensuration of shapes, and we're told that the total surface area of a cone of slant height L centimeters and base radius R centimeters is 224 pi centimeters square. Then, if the ratio of R to L is given as 2:5, we're to find correct to one decimal place the value of R, and then correct to the nearest whole number the volume of the cone. And for this question, we can take pi as 22/7. Now, here is a pictorial view of what we are asked to actually work with, in which we have the cone of slant height L centimeters. So this is L, okay, and then the base radius R is, this is the base radius R. So from the question, we are told that the total surface area of the shape is 224 pi, and then we're also told that R ratio L is equal to 2/5. Okay, that's the mathematical expression for this. R over L is 2/5. Now, we are asked to find, in the first case, the value of R. If we want to find R, we know that the expression for the total surface area is given as pi R square corresponding to the circular base plus pi RL corresponding to the upper part. But in this particular question, look at this. We are given the total surface area as 224 pi. Okay. Now, of course, we have even pi. We don't have problem with that. But R and L, they are expressed with respect to one another. So, what would have been ideal is for us to actually express one of them in terms of the other. And looking at the question, we are asked to find the value of R. So, we should let R reflect in the solution we are trying to procure. So what could have been ideal for us to do is to say that from here, if we cross multiply, we can say that L to L is equal to 5R, so that L will be 5/2R. Now, I'm using this because, look at this, it's the value of R that we are looking for. So R should reflect in that equation since we are not needing L. So for R to reflect in that situation, we can now say that means that our total surface area, which we are given as 224 pi, we can say this is now 224 pi is equal to, look at these two entities. We can see that pi is common to both, so we can just factor out pi, okay? Then even R is also common to both, so we can also factor out R. So here we just have R remaining plus here we have L remaining, but instead of L, look at this. L has been expressed as 5/2R. Okay, in short, I can also see that R again is common. So first I can see that pi is common and I can knock that out, and then I can have this to be 224 is equal to R. Initially we have here another R is also still being expressed here. So I can say that is R square multiplied by 1 plus 5/2. Okay. So if I want to express this correctly, I can just say this is 224 is giving me R raised to the power 2. 1 plus 5/2, I can express the LCM as 2. 2 divided by 1 is 2. And here I have 2 times 1 to be 2 plus 2 divided by 2 is 1. 1 times 5, that is 5. Such that I can have 224 is equal to R square multiplied by 2 plus 5 is 7/2. And here, if I cross multiply, I can have it that from here, R square is now going to give me 224 times 2 over 7. Okay, so if I want to express that, I can say r squared is equal to 224 times 2 divided by 7, that is 64, so that r itself will be the square root of 64. So the square root of 64 is 8 centimeters, but here we are told to evaluate it correct to one decimal place, so to just do that is 8.0 centimeters, and that is the solution to this particular question. Now we've been able to do this because we are able to know that from the ratio that we are given, we can express L in terms of R, and since R is what we are looking for, that's why we are doing that. I don't mean that we are looking for L. We could have expressed R in terms of L and then substitute back such that L would have reflected. But here, we want R to reflect since that's what we are asked to find. So, the radius of this particular cone is 8 centimeters. And we can just reflect that to be, this is 8 centimeters. Alright, so we can now move to the second question. So, in the second question, we're asked to find the volume of the cone. Okay. The volume of the cone is what we're asked to find here. But recall that initially we are saying that we have R over L to be 2 over 5. And now we have gotten the value of R. But from here we can say that, the other time we cross multiply and we got that L is equal to 5 over 2R. And here that we have gotten the value of R to be 8 centimeters. We can say that means that L is equal to 5 over 2 times 8, and this 2 can cut it to give us 4, so that L is 5 times 4, and that is 20 centimeters. Okay, now L being 20 centimeters, we are finding this because we are going to need that to evaluate the volume of the cone. Now, what's the formula for the volume of a cone? The volume of a cone is expressed as 1 over 3 multiplied by pi r square h, where h is the vertical height of the cone. So for that, we can just express it as, this is h, this is h here, and recollect our L we just got to be 20 centimeters, so L here is 20 centimeters. We have our R to be 8 centimeters, and you can see something is coming out already because the radius and the height, the vertical height of the cone, are actually inclined at a right angle. Here, this is a right angle. And by the Pythagoras theorem, we can see that the square of the hypotenuse, which is the longest side, or the side facing the right angle, that is 20 raised to the power 2, is equal to the sum of the square of the other two sides. So that is equal to 8 square plus h square. Okay, that's the statement of the Pythagoras theorem, such that h raised to the power 2 will be 20 square minus 8 square. Now, that implies that h raised to the power 2 is 20 square is 400, 8 square is 64. So, h raised to the power 2 is 400 minus 64 will give us 336, and h will be the square root of 336. Alright, so I can just keep that and use directly in the formula for the volume. So now that we know the parameters that we need, pi we have been given to be 22 over 7, r we have gotten to be 8 centimeters, h we have gotten to be square root of 336. We can now go ahead to evaluate the volume of the cone to be 1 over 3 multiplied by pi is 22 over 7 multiplied by r raised to the power 2. R raised to the power 2 will be 8, so this will be 8 raised to the power 2 over 1, okay, multiplied by h is square root of 336. And so we can just take our calculator to express all of this out, that 1 over 3 times 22 over 7 multiplied by 8 raised to the power 2 multiplied by the square root of 336. What's that going to give us? This is going to give us 1229.00 1229.000 3158. 3158. Now, if you look at the question, we are seeing that we are asked to find this correct to the nearest whole number. So, if you want to just use the nearest whole number, we won't be using any of the decimal places. And you can see 0 actually is not going to be significant to add to this. So, the volume of the cone is 1229 centimeter cube. Don't forget to put your unit. That will earn you your full mark. And with that, this particular question we have correctly solved and we are done with it. This is a question on probability, and we are told that a die was rolled a number of times and the outcomes are shown in the table. So here is the table in which the number of the die are shown at the top and the outcomes are shown at the second row. Now we are told that if the probability of obtaining 2 is 0.15, we are to find the value of m, the number of times the die was rolled, and the probability of obtaining an even number. So in the first case, if we were to look at the value of m, we are told that the probability of obtaining 2 is 0.5, and here when we look at the feature for the number 2, we are saying that the outcomes is being denoted by m, and we don't know what that m is. But if you could recall, the probability is defined as the desired outcome over the total possible outcome. So this is desired outcome that we are looking for out of all the possible outcomes. So we have a desired outcome over the possible outcomes. So if you want to make use of this particular equation, we can say that for this particular die that was being rolled, the desired outcome to obtain 2 is m. You can see that is m, and then the possible outcome is the total of all these outcomes: 32, m, 25, 40, 28, and 45. So you can say our possible outcome for this particular case, the possible outcome is the addition of all the outcomes that we have, and that will be 32 plus m plus 25 plus 40 plus 28 and plus 45, and that's going to give us m. We don't know, so we just know this is m plus, it is m plus another value, and that value is going to be, okay, we have 32 plus 25 plus 40 plus 28 plus 45 again. Okay, that's equal to what? That is 170. So this total possible outcome is m plus 170. Plus, from the definition we have as probability is desired outcome over possible outcome. That means that our desired outcome, which is m, over the total outcome, which is m plus 170, is going to give us what? 0.15. Or you can just write it as 0.15 over 1. And all we have to do is just to solve for the value of m, and we can cross multiply this to say that we have m is equal to 0.15 m plus 0.15 times 170. 170 times 0.15 is equal to 51 over 2, which is 25.5 plus 25.5. So if we take m to the other side, we just have m minus 0.15 m is equal to 25.5. m minus 0.15 will be 1 minus 0.15, because this particular m is just as if we are having 1 as its coefficient. So this will be 0.85 m. 0.85 m is equal to 25.5. So in that case, m will be 25.5 divided by 0.85, and we have to get that on our calculator. 25.5 divided by 0.85 is equal to what? That is 30. So the value of our m from this particular question is that m is equal to 30. So what we've been able to do is that we've been able to use the definition of the probability as desired outcome over possible outcome, and here our desired outcome is m, which you don't know, over all the possible outcome, which is the addition of all these outcomes, and we equate it to the probability of obtaining 2, which we are given as 0.15, and solving we're able to get m to be 30. So we can go ahead and try and solve these other two questions that were asked. So here in the first case, we've been able to get m to be 30, and here in this second question, we are told that we are to find the number of times that the die was rolled. The number of times that the die was rolled is going to be the addition of all these entries, all of the outcomes. So that number of times is going to be the addition of all the outcomes. And if you recollect, we have just gotten the addition of all of these without m to be 170, and if we add them to it, you can say it's just 170 plus m, and the value of m is 30. So the number of times the die was rolled is 170 plus 30, which is 200. Okay, and then the last question here, we have to find the probability of obtaining an even number. Probability of obtaining an even number. So first, for us to do that, we know that will give us the outcomes of even number over the total outcomes. Now the total outcomes is going to give us 170 plus 30, which is the addition of all this. But where are the even numbers for this particular question? You can see 2 is an even number, 4 is another even number, and 6 is another even number. So that means that the probability of obtaining an even number is going to be the outcomes of all the even numbers. Here we have, and this outcome is m, and m will go to be 30. So we have this as 30 plus the outcome of 4 as an even number, which we are given to be 40, okay, plus the outcome of 6, which is another even number, which we are given to be 45, okay, over the total outcomes for all the numbers of the die, that is 200. We just evaluated that. So this is going to be 30 plus 40 is 70, 70 plus 45 is 105 over 200. And we can just simplify that by looking at the barest division, or I can just use my calculator to say this is 115 divided by 200, and that is 23 over 40. So this is 23 over 40, which is obtained by dividing both sides by 5. So 5 here is 23 and 5 here is 40. So the probability of obtaining an even number is 23 over 40. And you can see how the father we've been able to evaluate the value of m to be 30, and able to get the number of times the die was rolled to be 200, and also able to evaluate the probability of obtaining an even number to be 23 over 40. And with that, we have finished this question on probability as requested. So here is a question on a graphical solution to a trigonometric function that we're asked to copy and complete the table of values for the relation y is equal to 3 sine 2x. And here is the table of values. So we're told to use a scale of 2 centimeters to 15 degrees on the x-axis and 2 centimeters to 1 unit on the y-axis to draw the graph of y is equal to 3 sine 2x for values of x ranging from 0 to 150 degrees. Okay, so we are to use a graph to find the truth set. This statement means that we should find the solution of these equations, and in the first case 3 sine 2x plus 2 is equal to 0, and 3 over 2 sine 2x is equal to 0.25. So like we're told, our first mandate is to copy and complete this table of values for the relation y is equal to 3 sine 2x, and we are going to be taking values of x from 0 15, 30, 45. But we need to note something. This is where students most likely will make mistakes. You will forget that we are told to use 2x. Look at this question. It is 3 sine 2x. And I'm going to show you on the calculator. You can do that seamlessly. So if you bring in your calculator, this is a very good way to do this. This is just a basic calculator, not too scientific, but you can actually play around it to also try and see how to solve it. We have 3 sine 2 times. Now, we now need to input the values of x as we are given on the table. Like in the first case, we have x is 0, so it is 2 times 0. So I can close the bracket and say this is equal to what? It is 0. And you can see as it was given on the table, we have the value of y to be 0 when x is 0. So that was given already and we don't have any problem with that. But what about the second situation in which the value of x is 15 degrees? So you can just press the back button on your calculator and instead of 0, you put in 15 and this is going to be 3 sine 30 because 2 times 15 is 30 and that will be 3 over 2 because sine 30 is 1 over 2, that's half. Times 3, that will be 3 over 2. So you can just express this in decimal and that is 1.5. So here we have 1.5 as the value for y. And then just like that, we will continue by going back to change the value of x. And here in the next one, we've done the one for 15. Then we need to do the one for 30. So 3 sine 2 times 30. And you can see the value here in decimal place is 2.59807611. But if you notice the consistency with which they input these values, they are given in 1 decimal place. So we need to convert this also to 1 decimal place. And if we are going to do that, that means that the 9 that is after the decimal place we want to take, we either round it up or round it down. In short, numbers between 5 to 9, we need to round them up to 1 and add to the number just before them. So 9 we take as 1 and add to 5. So we have 2.6 as the value. So here will be 2.6, alright? And then you can just go on like that. When x is 45 degrees, instead of 30, we have 45. What's that solution? That is 3. We want to put it in 1 decimal place. That will be 3.0. And then when x is 60, you just want to change this. So this is 60. So what's that? This is also 2.6 in 1 decimal place. So this is 2.6. And unlike that, you can just input all your values. When x is 90, so what's the value for y? Y will be 0. So this is 0.0, just like they did here in the first case. So when x is 105 degrees, 105 degrees, okay, y is minus 1.5, minus 1.5, and then when x is 120 degrees, you can see I'm being consistent such that I'm not going to make mistake of forgetting to multiply by 2. So this is going to give me minus 2.6 in 1 decimal place or so, okay. And finally, when x is 135, 135, what's the value of y? That will be minus 3.0 in 1 decimal place. So that is a very good means in which you can be sure that you won't make any mistake by forgetting to multiply x by 2. Okay, so that is the first mandate. We have copied and we have completed that table as requested. So we can now, before we draw our graph, okay, before we come up with the solution to the graph and plot the graph, let's look at this question 6c, in which we have to find the truth set of 3 sine 2x plus 2 is equal to 0 and 3 over 2 sine 2x is equal to 0.25. Now, the mandate for us is that we should try as much as possible to reflect y in these particular equations. And in the first case, look at what we are given. In the first case, we are told that 3 sine 2x plus 2 is equal to 0. And looking at the equation, look at this. We already know that y was given as 3 sine 2x. And that means that this first expression in the equation is nothing but y. So we can say y plus 2 is equal to 0, such that the value of y will be minus 2. Now, minus 2 is just a constant, so it's not depending on x. There's no variable that is being reflected there. We just know that y is minus. So it's going to be a straight line graph that is constant across the axis of the x values that we are going to be considering. Okay, it's going to be constant across the x-axis of the graph. So that's just y is equal to minus 2. What about the second case in which we are told that 3 over 2 sine 2x is equal to 0.25? Yes, already we know that 3 sine 2x is x. So this particular equation, I can rewrite it to be, this is the same as 1 over 2 multiplied by 3 sine 2x to give me 0.25. And look at this, 3 sine 2x, is that not y? So I can just write y and say this is 1 over 2 multiplied by y is equal to 0.25. And I can say this is over 1. So if I cross multiply, that means y is equal to 2 multiplied by 0.25. Okay, and 2 multiplied by 0.25 is 0.5. Okay, so y is 0.50 here, and here we have y is minus 2.0. So for the two of them, the value of y is constant, so it's not going to depend on x, meaning that it's going to be a straight line graph that is running across the length of the x-axis. It is just constant, minus 2 in the first case, 0.5 in the second case. So now that we have all that we need to plot our graph, we can go ahead to plot our graph and find the truth set of this solution as requested. Alright. So we need to look at our table of values to see how we can divide the graph to accommodate these values appropriately. It doesn't need to be at the origin, at the center. We just need to look at the values that we have, and it's going to help us to know where we can put the origin of the graph so that we will be able to input all our values as appropriate. Now, if you look at the values for y, you can see that y is increasing in the positive and the negative axis. So we can just know that. That means we can divide the graph into two equal parts to cater for y. So we can just go ahead to do that. Now for the x, we have how many values for x here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are 11 values for x, but the graph, the standard graph, is ideally 12 divisions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that means I can actually choose to start from this particular first box, and it will be able to cater for all the values that we have. So vertical axis can be drawn here just to cater for all the values of x that we are noticing on the graph. So we can just draw our straight line there, the origin 0, and this is the positive y, okay, and this is the positive x. Okay, so now if we want to scale appropriately, we've been told that we need to have 15 degrees represented by 2 centimeters on the x-axis. So this will be 15, 30, 45, 60, 75, okay, and 90, 105, 120, 135, and 150. Alright, so it's because I was able to scale my graph correctly. That's why you can say from 0 to 150, they are taken appropriately on the x-axis, and then on the y-axis, 2 centimeters to represent 1 unit. So this will be 1, this will be 2, 3, and 4, and 5. Okay, and this will be minus 1 because we have negative values. Minus 2, minus 3, minus 4, and minus 5. So our scale on the graph is quite interesting. We are done and dusted with that. Then in that case, we now need to look at how we can plot these values to one another. Like in the first case, when x is 0, y is also 0. So here at the origin, we have x is 0 and y is 0. And I'm using my blue ink to indicate that so that students out there you can see this clearly, okay? So when x is 15 degrees here, 15 degrees, y is what? 1.5. So this is 1, okay? And this is 2. In between them is going to be 1.5. But for x, that is 15. So I can just say I want to trace like this. 15 going up, okay? And then 1.5 coming in between 1 and 5. And the point of intersection here is the point that is corresponding to x 15 and y is 1.5. So I will just note that, and I can just directly notice it is going to be here. Alright. Okay, so when x is 30, y is 2.6. So this is x is 30 here. Y is going to be 2.6. Now, this is 2, this is 3, and here I have 1, 2, 3, 4, 5 divisions of my boxes. So, if that's the case, I will just need to take it as this. The first one here is 2.2, this will be 2.4, this will be 2.6, this will be 2.8, and then you can see it's not 3.0. I'm just having incremental values of 0.2 units. So, if I'm going to just take that, I can easily see that 2.6 is coming somewhere here. And the point of intersection here is what I need to note. So if I'm to know that, I will see that it is just coming here on the graph. That is the graph for, that's the point of intersection for x to be 30 and y to be 2.6. And then when x is 45, y is 3, that is quite straight. And now, because it's a trigonometric graph, it's going to be a sinusoid. It's just repeat, like it's going in this positive axis, it will also decline with the same value. And that is why you can see when x is 60, y is what? 2.6 again. So it's just here. You can see that it's symmetrical with this initial value, just on the same line, 2.6 and 2.6. In the second case, it will be 75 and 1.5. So 75 and 1.5 that we got initially. You can see how it's shaping out to be symmetrical. When it is 90, when x is 90, y is 0. So here we have the 0 and 90. So when x is 105, y is minus 1.5. And just like we got it initially, this will be 105 and minus 1.5. When x is 120, y is minus 2.6 and minus 2.6 is going to be here. Just a reversal of what we did on the positive y-axis, okay? When x is 135, y is minus 3.0. So 135 and minus 3.0 just here. And then when x is 150 degrees here, again, it is minus 2.6. So minus 2.6 here. Oh, interesting. So that's how a sinusoidal curve looks like. And then the task that is now left for us is to join all these dots together and get the sinusoidal curve as appropriate. And that's what I'm going to do. For you, the student out there, you can easily make use of your French curve, or if you have a very flexible material, maybe a broomstick, or there is a rubber curve that is normally available in the market, you can also use that. But here, in my digital tool, I'm just going to use freehand, but I'm going to try as much as possible to ensure that all the lines are joining together and it's going to form a sinusoidal curve, alright? So, let me just try and do that. Alright, so that's my sinusoidal curve, and of course we are stopping at 150 degrees like this. So this is the curve for y is equal to 3 sine 2x. As a rule of thumb, always make sure that you label your graph, okay? This is the answer to question A, this is the answer to question B, and then we need to look at the solution to question C. And here we are told that 3 sine 2x plus 2 is equal to 0. But we've been able to ensure that this is the same as y is equal to minus 2. Okay, So we can just draw our straight line. This is -2 on the vertical axis, and we can just plot our graph straight. So we can also correctly label this to be 3 sine 2x plus 2 is equal to 0. Or you can say y is equal to -2. Okay? Any one of the two will be suitable for you to define that. So for us to find the true set of this, we need to look at the point of intersection of this straight line graph and the graph that we are looking at initially. So this is that point of intersection, and we can trace it to the x-axis to just get that particular value. So that is quite straight. Let me just make that some broken line so that you'll be able to see it appropriately. So how do we get the value for this particular solution here between 105 and 120 degrees? Okay, we are going to look at it this way. Here, there are 5 divisions in the box that I'm considering as 2 centimeters. So I can say 5 is corresponding to 15 degrees, because between 105 and 120 is an incremental value of 15 degrees. You can see we are told 2 centimeters to 15 degrees on x-axis. So I want to get what one box will correspond to, so I can call that x. If I am to cross multiply, I can say 5x is equal to 15 degrees, such that if I divide both sides by 5, x, which is the value for each of the box, is going to be 15 over 5, and that is 3 degrees. So that means that in this particular case, each of these small boxes will take 3 degrees. So I have 105 plus 3 is 108 plus another 3, that will be 111 degrees. Alright, so I can say in that case, for y is equal to -2, the truth set is given as x, such that x is equal to 111 degrees. To leave some margin for errors, you can say plus or minus 1 degrees. Okay, so what I got originally was 111, but I'm just leaving a margin for error of 1 degrees, and that will be the solution to 3 sine 2x plus 2 is equal to 0. But that's not all. In the second case, we're told that 3 over 2 sine 2x is equal to 0.25. Okay, and for that, we are able to get the expression of y to be y is equal to 0.5. Okay, so for y is equal to 0.5, we just need to go to the point at which we have 0.5, which is on the positive y-axis, and that is here. So we draw a straight line, okay, just to cut the graph for the sinusoid that we have initially. So we're going to have something like this. So that's our curve for y is equal to 0.5. And you can see, different from what we had initially, here we are going to have 2 solutions, one here and one here. And just like we did before, we can just trace that down, and also here, trace it down. In this first case, we have incremental values of 3 degrees. So here is 3 degrees, here's another 3 degrees, that is 6 degrees. But this, our solution, is closer to 6 degrees, so we can say it's like 5 degrees. So the true set here, the true set for this second case is defined as 2 cases here. So we have it defined as, in the first case, x, in which x is equal to 5 degrees plus or minus 1 degree, okay, or x, in which x is equal to, what's the other solution? Here we have 75, okay, and we have 1, 2, 3 boxes. So we have incremental values of 3. So 3 in 3 places, that will be 9. So 75 plus 9, that will be 84. So we have 84 degrees plus or minus 1 degree. So this will be the solution to this other equation in which we are told 3 over 2 sine 2x is equal to 0.25. So we can reflect that here, that this is the graph for 3 over 2 sine 2x is equal to 0.25. Or, like I said initially, you can say it's just y is equal to 0.5. Either of these two, defining the straight line graph will be sufficient. Okay, and just like that, we've been able to look at this question holistically and provide the solution that we're asked to actually provide as appropriate. Here in this question on mensuration, we are told that this diagram, shows a wooden structure in the form of a cone mounted on a hemispherical base. So we need to know that this is a hemispherical base. Then the vertical height of the cone is 48 meters and the base radius is 14 meters. We have to calculate, correct to 3 significant figures, the surface area of the structure, and we can take pi as 22 over 7. So now this is the shape and this is the diagram that we are being given, and we have to actually calculate the surface area of the structure. But we need to note something. First, we are told that it's a wooden structure in the form of a cone. Look at this. It's a wooden structure in the form of a cone and mounted on a hemispherical base. These are indications that we are not talking about 2D. It's not 2D. Rather, we are talking about 3D. Something like this is what we are talking about, and you can see here at the top, the wooden structure, we have the shape of a cone, and then it is mounted on a hemispherical base. So this is the hemispherical base, and this is the cone that is the uppermost structure. So if we want to put the information that we're given, we can just denote that yes, the vertical height of the cone from here down to here, that was given as 48 meters. But then we're also told that the base radius is 14 meters. Now, this is the base, and the radius we mean from the edge of the circumference to the center. So we have this is implied at right angle, and we're told that the vertical height is 48 meters here, and then the base radius is 14 meters. This is 14 meters. So now, since the cone is sitting directly on the hemispherical base, that means that the radius of the hemispherical base is also going to give us 14 meters. So from that circumference to the center of the hemispherical face, we also have this to be 14 meters. Now, if these are the two shapes that we are concerned about, how do we go about to find the surface area of the structure? You can see here that the surface area of the structure will give us the surface area of this particular cone and then this hemispherical base, this hemisphere. Okay, so we can say that the surface area of the shape is going to give us the addition of the surface area of the cone and the surface area of the hemisphere. So if we can get the surface area of the cone and we can also get the surface area of the hemisphere, if you add them together, that will give us the surface area of this particular shape that we're asked to find. But now, what is the formula for the surface area of a cone? That is going to be pi RL. Now, pi we are given to be 22 over 7. The radius is the radius of the base of the cone, which is 14 meters. Then the slant height L. But looking at this particular diagram, we don't know the slant height L. We have the vertical height to be given as 48 meters. It is L that we're asked to actually use. But then no problem, we're going to add that to the surface area of the hemisphere. Now, the hemisphere is half of a sphere. So we can say if we want to find the surface area of the hemisphere is half multiplied by the surface area of a sphere, which is 4 pi r squared. So this is the formula that will help us to get the surface area of this particular shape. So now we need to actually look to see how we can solve this particular question, because for us to solve for the surface area of the cone, we need the slant height. And if you look at this diagram, you know, we are given that this is L, this is point M, and this is point N. Okay, from the diagram we can see that ML, so if we call this O being the center of the conical base, we can see that triangle MLO constitutes a right angle. And for that we can make use of the Pythagoras theorem to actually get the slant height of the cone, which is L. And we can get that by saying that that is going to be the square of the hypotenuse, which is LM square, is equal to the sum of the square of the base and the vertical height, which is going to correspond to the adjacent and the opposite if we take the angle here or here. So that will be OM raised to power 2 plus OL raised to power 2. LM is L, so we can just say L raised to power 2 is equal to OM is 14, so we have 14 raised to power 2 plus OL, that is 48 raised to power 2. So if you are to use our calculator for that, we can say 14 raised to power 2 plus 48 raised to power 2, that's equal to what? 2,500. So this is 2,500, such that L will be the square root of 2,500 and the square root of the answer that we just got is 50. So L is 50 meters. Okay, so we can just append it here that L is 50 meters from the fact that we employed the Pythagoras theorem to solve for that. So can I use the value of that slant height L to actually compute the surface area of this particular shape? And then I can just put in the value that pi is 22 over 7 multiplied by R, that is 14, okay, multiplied by L, that is 50, and that is the surface area of the cone, plus now half multiplied by 4 is 2, so I have this as 2 times pi is 22 over 7 times the radius is also 14, just like in the first case, and we have it as 14 square. And this, if we are actually going to evaluate it, let's do that piecewise, or even first, let's say here I can say 7 can cut 14 to be 2. So in the first case, we are going to have 22 times 2, 22 times 2 times 50. That will be 2,200. So this is 2,200 plus, in the second case, given 22 over 7 and 14 square can cut. No problem. I can just say 2 times 22 times 14 raised to the power 2 divided by 7. That's 1232 plus 1232, which happens to be the surface area of the hemisphere. Okay, now 2,200 is surface area of the cone, and then 1,232 is the surface area of the hemisphere. The surface area of the shape will be the addition of these two, and if we are to evaluate that, say 2,200 plus 1232, that's going to give us 3,432. So 3,432 meters square, but we are asked to get it correct to 3 significant figures. So if you want to make it to 3 significant figures, meaning that the vital digit that we need to see should be 3. And now if we are to take it, here we have the first one, the second one, and the third one. We should consider 2 and see if we need to round it up or round it down. 2 is not up to 5. Numbers between 0 and 4 will round down to 0 and add to the previous number. Numbers between 5 and 9 will round up to 1 and add to the previous number. But since 2 is not up to 5, that means we can just have our final answer as 3,430 meters square as the surface area of this particular shape. What we just need to note as students is that we should not be confused with this shape and think it is a 2-dimensional diagram and say, yeah, this is a triangle and then here this is a semicircle. No, because we are talking about a wooden structure which is a physical shape. It is 3-dimensional, and that's why we should be talking about a cone and an hemisphere. And just using the formula for the surface area of the cone and the surface area of the hemisphere, which is half of a sphere, we can go ahead to evaluate by first finding the slant height and then imputing correctly into the equation to solve, and our final answer is 3,430 meters square. Here in this question on word problem on simultaneous equation, we are told that 5 years ago, Musa was twice as old as Sese. Now, if the sum of their ages is 100, we are to find Sese's present age. We need to distinguish something very clearly. We have two case scenarios, okay? There are two case scenarios that we are looking at here. First, 5 years ago, and then the present time. So, we need to represent these two time lines correctly for us to be able to solve our question. Now, we are told that the sum of their ages is 100. In that case, if I say that Musa's age should be, let Musa's age, let it be X, and Sese's age, let it be Y, we'll be able to interpret our questions mathematically if we are to do that. First, we're told that the sum of the ages is 100. That means X plus Y is equal to 100. That's presently. But we're told that 5 years ago, Musa was twice as old as Sese. So what's Musa's age 5 years ago? Since he's X today, 5 years ago, it will be X minus 5. Okay, that's 5 years ago for him. But for him, he is twice as old as Sese. So if X minus 5 is Musa's age, then Sese's age should be X minus Y 5 years ago. But we are told that the age of Musa 5 years ago is 2 times the age of Sese 5 years ago. So these are the two equations that we need to note and work with, and we can say that this is equation 1 and this is equation 2. Well, we are to find Sese's present age. Sese's present age is Y. So Y is our point of interest in this particular case, okay? But I can look at the equation and I can say from equation 2, and you can actually use any method of solving simultaneous equation to solve this, because already you can open this bracket and notice that this is just nothing but a simultaneous equation. But from 2, I can say Y will be, or since I'm looking for Y, I can eliminate X. So I can say X is equal to 100 minus Y. So this is what I can say. I can call equation 3, and I can use in equation 1. Okay, so from 2, I've found the value for X, and that value for X in equation 1, wherever I see X, instead of writing X, I'm going to write that value for Y. So in that particular case, what I'm going to have is that instead of X minus 5, I'm going to have that as 100 minus Y, okay, which is X, then minus 5, okay, is equal to 2 multiplied by X. What is X? X is 100 minus Y. Then again, I still have this minus Y. So we have to simplify this. 100 minus 5 is 95. So I have 95 minus Y is equal to 2 times 100 is 200. Then minus Y is minus 2Y times 2. That will give me minus 4Y. And here, if I collect like terms, if I say let minus 4Y move to the left hand side, it will become 4Y. Then minus Y is equal to, here, 200. When 95 moves to the right hand side, become minus 95. So 4Y minus Y is 3Y. And that's equal to 200 minus 95 is 105. And from here, I can just say, yes, from having 3Y is equal to 105, I can divide both sides by 3. And here, already I can see that 3 here can cut 3 here. I have 3 here, 1. 3 in 10 is 3, remaining 1. 3 in 15 is 5. So, for that particular case, Y, which happens to be the age for Sese, is equal to 35 years. And, X was what we are using to denote Musa's age. Y was what we are using to denote Ceci's age. They are not asking us for Musa's age. They are asking us to find Ceci's age, and that is 35 years. So, understanding how to interpret our timeline question, okay, had helped us to simplify this question into a set of simultaneous equations in two variables. And here we just use the substitution method to substitute for the value of x from the second equation into the first equation, and simplifying, we're able to get y, which is Ceci's age, to be 35 years. And that's the solution to this question. Here in this question on commercial mathematics, we're told that Miss Maureen spent 1/4 of her monthly income at a shopping mall, then 1/3 at an open market, and 2/5 of the remaining amount at a mechanic workshop. So we need to take note of that so that we don't get confused. Then after spending all of this amount, if she had 225,000 naira left, we are to find her monthly income and the amount she spent at the open market. So the ideal approach is for us to represent our monthly income by x. So we can say let x be our monthly income. It as our monthly income, we can now work around trying to extrapolate all the values that we are giving so that we can arrive at the solution to the question we are given. In the first case, we are told that she spent 1/4 of her monthly income at the shopping mall. So the shopping mall will take x/4, okay, and then she spent 1/3 of her monthly income at an open market. So this is going for the shopping mall. Then x/3 is going for the open market. Let me use that as O. Then 2/5 of the remaining amount at a mechanic workshop. How do we get first the remaining amount before we evaluate 2/5 of that remaining amount? Okay, so first we can say the remaining amount will be x, which is the total amount, minus the sum of the amount she spent at the shopping mall and the open market. So that will be x/4 plus x/3. So if you want to get this is the same as if we just have x minus, looking at the expression in bracket, we can find the LCM. 4 and 3, the LCM is 12, and 12/4 is 3. 3 times x will be 3x, and here we're having an additional sign. 12 divided by 3 is 4. 4 times x is 4x, and this is going to give us x itself is just as if we're having 12x/12. I just want to do this to simplify it. Then minus 3x plus 4x is 7x/12. So the remaining amount, after spending some of our income at the shopping mall and at the open market, will be 12 minus 7. That will be 5x/12. But we need to note something. We are now told that she spent 2/5 of that remaining amount at the mechanic workshop. So meaning that the amount that she spent at the workshop will take 2/5 of 5x/12. This is where students most likely will make mistake. We need to note that it is 5x/12 that is remaining after she spent money at the shopping mall and at the open market. So the amount she's now spending at the mechanic workshop is 2/5 of that remaining amount. So this will be 2/5 multiplied by 5x/12. So you can see 5 can cancel 5. 2 can be used to divide 2 here. 2 in 12, that is 6. So this is x/6, meaning that the amount she spent at the workshop is x/6. Now, let's look at these three statements, because we are now being told that if she had 225,000 naira left after spending all of this money, then we have to find her monthly income and the amount she spent at the open market. Now, what is the implication that she is having 225,000 left? That means that out of her total monthly income, we need to take out the amount she spent at the shopping mall plus the amount she spent at the open market plus the amount she spent at the mechanic workshop. So we subtract these three amounts from our total monthly income, which is X. And that is what we are going to be doing now. And that is the interpretation that students really need to note to get this question correctly. So the total amount left now, after spending everything, the total amount left is going to be X minus all the money that she spent in all the places she went to, which is X over 4 spent at the shopping mall plus X over 3 spent at the open market plus X over 6 spent at the mechanic workshop. So this, we know it to be X minus the LCM of these three, 4, 3, and 6 is 12, and 12 divided by 4 is 3. 3 times X, we have 3X, plus 12 divided by 3 is 4. 4 times X, that is 4X. 12 divided by 6 is 2. 2 times X, that is 2X. Okay? So that total amount left is going to be X minus 3X plus 4X is 7X plus 2X, that is 9X over 12. Okay? And so if I'm to also find the LCM, this will be 12 as the LCM. And here we're going to have 12x minus 9x, because this is just as if I'm having x over 1, and 12 divided by 1 is 12. 12 times x, that's 12x. So this is going to give me 3x over 12, and I can use 3 to divide both the numerator and denominator to have this as x over 4. So now if you want to take note of what we have done so far, we've been able to find that the amount she spent at the workshop is x over 6. That's the amount they spent at the workshop. And after spending all of this money, the amount remaining, okay, the remainder is x over 4 as we evaluated here. So I'm going to I've taken note of all these calculations. I'm going to clear this so that we can answer the questions that were asked as appropriate. So now to find our monthly income, which is the solution to the first question that we are going to be dealing with here, we're told that if she had 225,000 naira left, we need to know that that amount that she had left is corresponding to this remainder that we have as x over 4. Okay, so that implies that the amount left, which is x over 4, is corresponding to 225,000 naira. So from here, if you just cross multiply, we can say therefore x is 225 times 4. 4 times 225,000 naira. If you want to get that, we just say 225,000 multiplied by 4. That's what? That is 900,000 naira. So this is 900,000 naira as the solution to the question of we finding our monthly income. In the second case, we are told that we are to find the amount she spent at the open market. Now, the amount she spent at the open market, what did we use to represent that initially? We are told that is 1/3 of our total monthly income that she spent at the open market. So, amount she spent at the open market, is given as 1/3 of x, which is our total monthly income, and that will be 900,000 divided by 3. Okay, 900,000 over 3 is 300,000, and that is the solution to this question. What we just need to note is that we need to just take our monthly income, which is x, to be a value that we can use fractions on, and that's where we started. 1/4 at the shopping mall, 1/3 at the open market, then 2/5 of the remaining amount at the mechanic workshop. We need to first find that remaining amount and then evaluate 2/5 of it, which will got to be x over 6 as the amount spent at the mechanic workshop. Then the remainder, after spending the 3 of this, the total remainder which she had left was obtained as x over 4, which corresponds to 225 thousand naira. So for us to find our monthly income, we just need to say x over 4, which is the remaining amount, is equal to 225,000, and then we can find the monthly income x. So I can just append this as monthly income x. The monthly income x was obtained now as 4 times 225,000, which is 900,000, and then the amount spent at the open market, we are told initially it is 1/3 of our monthly income, and 1/3 of 900,000 is 300,000, and that is the solution to our question here. In this question on arithmetic progression, that is sequence and series, we are told that the third term of an arithmetic progression, an AP, is 4m minus 2n, and if the ninth term of the progression is 2m minus 8n, we are asked to find the common difference in terms of m and n. So for us to solve this question, what we need to note first and foremost is that the nth term of an AP is given as a plus n minus 1 multiplied by d, where a is the first term, n is the nth term, and then d is the common difference. So now if you want to consider the third term, which was given as 4m minus 2n, we know if you want to make use of this equation of the nth term of an AP, that is the same as a plus n, in this case is 3, and we have it as 3 minus 1d, such that we can say here, if I want to write this on the left hand side, I can just say a plus 2d is equal to 4m minus 2n, okay? And then in the second case, we are talking about the ninth term, t9. If we want to express the ninth term, we are given as 2m minus 8n. So this is also equal to a plus, now the nth, the term we're talking about is the ninth term, so our n is 9 minus 1 multiplied by d. And if we want to express just like in the first case, we'll have this as a plus 9 minus 1 is 8, so we have 8d is equal to 2m minus 8n. Now this 2 is actually a set of simultaneous equations, which you can call this equation 1 and we can call this equation 2. Now what are we asked to find? We're asked to find the common difference in terms of m and n. So m and n, okay, is just a value that we can work with. We can say this is actually solvable because we have two unknowns and we have two equations and we can actually solve that, not considering m and n, since our answer is going to be in terms of m and n. And because we are not looking for the first term a, look at the question, we are told to find the common difference. Then we can eliminate a out of this equation so that we can solve for d. And for me, I think it will be good if we say we subtract equation 1 from equation 2. So I can say equation 2 minus equation 1 will warrant that in the first case, a minus a, you know it's right, I'm saying 2 minus 1. So a minus a will be 0. 8d minus 2d is equal to, here I have the 8d from the second equation minus 2d from the first equation is equal to, here, 2m minus 4m, this first entity, okay? Then here, look at it, you have minus 8n here. I'm just writing down minus 8n. Then minus 2n. Or, better still, if I want to write this out just straight so that you don't get confused, I can just say it's 2m minus 8n. Here, the one in equation 2 minus 4m minus 2n. Alright, so 8d minus 2d is 6d is equal to, we have 2m minus 8n. Now I'm trying to open this bracket. I still have minus 4m, but in this particular case, minus will multiply minus, so giving me a positive sign. Then I have that 2n still remaining. So this is 6d is equal to 2m minus 4m is minus 2m, okay? Minus 8n plus 2n is minus 6n. And I can see that a negative sign is common to this. So I can say 6d is equal to minus 2m, or even not only a negative sign that is common, I can say minus 2 is common to both sides, then I have m plus 3n, because minus 2 times m is minus 2m, and minus 2 times 3n is minus 6m. So since I have this, I can divide both sides by 6 so that I can find the expression for d, and then 6 here can cancel 6 here, and minus 2, I'm going to have minus 1, and then in 6, I'm going to have 3, such that the value for the common difference we have to find will be minus 1 over 3 multiplied by m plus 3n, and this is going to be the solution to this particular question. And that's how we can go about solving this question on arithmetic progression. In this beautiful question on bearing and distance, we are given that two cyclists x and y leave town q at the same time. Then cyclist s travels at the rate of 5 km per hour on a bearing of 049 degrees, and cyclist y travels at the rate of 9 km per hour on a bearing of 319 degrees. First, we are to illustrate the information on a diagram. Then, after traveling for 2 hours, we are to calculate to the nearest whole number the distance between cyclist x and y, and then the bearing of cyclist x from y. And finally, we are to find the average speed at which cyclist s will get to y in 4 hours. So here, our first mandate is to illustrate the information on a diagram. And looking at the question, we are told that they leave town q at the same time. So q will happen to be our point of reference. So if we are to locate point q and we draw our 4 cardinal points, this is a 4 cardinal point from where we are going to take our bearing from. And in the first case, we are told that the cyclist s travels at a rate of 5 km per hour on a bearing of 049 degrees, and cyclist y travels at the rate of 9 km per hour on a bearing of 319 degrees. So to locate the bearing of cyclist s, which is 049 degrees, if we take this as the north, the south, the east, and the west, and we are trying to locate the bearing of 049 degrees, that is going to be between north and this, because normally we start taking bearing from the north and we go in the clockwise direction like this. But here we are told it's 049, meaning that it's not yet a right angle. Between north and east is a right angle, which is 90. So 49 will be here in this particular first quadrant. So we can just take our bearing that will go from north, and this is 049. Okay, so we can just take that bearing to now go somewhere like this. So this is where the cyclist x will be. Okay, so that's the first thing we need to do. Then for the cyclist y, we're told that he is traveling on a bearing of 319 degrees. So how do we get 319 degrees? From the north to east, that is 90. From the north to the south, you can see it's a straight line, that is 180. From the north to the west, that's that 180 plus another 90, making 270. So from north to west is 270, and from north, making a complete circle, is 360 degrees, because that will now amount to the angle at a point. But here we are being told it is 319, so that will be in this last quadrant between 270 and 360. So you can just say we are moving somewhere like this, and this will be 319 degrees. So you can also take that bearing just straight up to where cyclist y will be located. So I think this is a good representation of what we have as that bearing. So if you want to label, we can say this is point Q, okay, then this is point X, and this is point Y. Something of interest that I would like us to note, I took this to be longer than X because look at the information that we're giving. we are told that the cyclist X travels at the rate of 5 kilometers per hour. So that is 5 kilometers per hour. This is for the X. But the cyclist Y travels at the rate of 9 kilometers per hour. And this is Y. Now, look at 9 kilometers per hour and 5 kilometers per hour. Of course, definitely, the one running on 9 kilometers per hour would have covered more ground, more than the one running 5 kilometers per hour. In short, I think my 5 kilometers per hour is way too long because 9 is almost twice the size for the X. So I should have it somewhere here. Okay. And that is where you paying attention to the details that was given will really help to solve the question that you are trying to solve. So I can say this is my X because Y would have traveled almost twice the length of X with the information that we are given. And why am I doing this? Is because you are going to get your diagram more correctly and you'll be able to solve the question better and easier. Okay, you won't have a drawing that will be negating what you are trying to postulate as the thing to get from the drawing. So good and beautiful like this. This is the information that we're asked to illustrate on a diagram, and it's like this. Now I want to just put some little effects. I want to bring in my cyclist, so let's just wait for that. So I love the fact that I brought in my cyclist to reflect on my diagram, just like we used to have on our textbooks. So then you don't need to show this. I just using this so that I can have a pictorial view of what I'm trying to talk about. You can see I'm reflecting that the person traveling at 9 kilometers per hour is traveling faster than the person moving at 5 kilometers per hour. And just to complete the triangle that we are drawing, we can use a straight line to join X to Y, just like this. And then we are good to go. I love this. So with this, we have the information illustrated in the diagram as requested, and then we can move on with the other questions. So now, after looking at the first question, we are being told here that after traveling for 2 hours, we are to calculate to the nearest whole number the distance between cyclist X and Y and the bearing of cyclist X from Y. Let's take it piecewise. To get the distance between the cyclists, look at all the information we are given. We are given the speed, and now we are being given the time to be 2 hours. Now, by reason of understanding of speed, distance, and time, we know that speed is defined as distance over time. Speed is distance over time. But normally, working with bearing and distance, even look at the word that we use. We say bearing and distances. So here we need to find the formula for the distance, and distance in this case is equal to the speed multiplied by the time. Okay, so this is what we ensure that we are working with the right values, because given the speed we need to get the distances that we work with so that we can even find the distance between cyclist X and Y. So for the cyclist X, after 2 hours, we can say after 2 hours, the distance covered by cyclist X, the distance covered by cyclist will be his speed multiplied by the time, and the speed we are given already as 5 kilometers per hour multiplied by the time, which is 2 hours. Now 5 times 2 is 10, but here we have kilometer per hour multiplied by hour. Now per hour means divided by hour, then multiplied by hour. You can see the hours will cut out and we have only the kilometer left. So that is actually the distance covered by cyclist X. And in the same vein, the distance covered by the cyclist Y will be, what's the speed for Y? It is 9 kilometers per hour multiplied by, they are using the same time, so we multiply by 2 hours, and that will be 9 times 2, that will be 18 kilometers. We now understand how to knock out the hours from the unit. So if you go back to our diagram, that is just telling us that the distance from Q to Y, that's the distance of the cyclist Y, is 18 kilometers. So here we have 18 kilometers, okay? And the distance from Q to X, distance of X is 10 kilometers. So we have here is 10 kilometers. But look at the question that we are being asked. First and foremost, we are to find the distance between cyclist X and Y. This is the line XY, which is facing Q. So here is what we are told to look for that we don't know. And For us to evaluate this, let's look at the diagram holistically, okay? If you are looking at this diagram holistically, look at this particular point. Here we're having a triangle and we don't even know any of the included angles. So starting from Q, where we're taking our bearing, let's see if we can find this angle so that we can use any of the mathematical rules that we have at our disposal to solve for this length xy, which will correspond to the distance between cyclists x and y. So here at point Q, originally we have this bearing of x from Q to be 49, and then we have the bearing of y from Q to be 319, but we can say we want to look for this particular point, this angle. And how do we find that? Look at it. From north to north is the angle at a point, and that is 360 degrees. And from that 360 degrees, we have already taken 319 out. So this particular place will be 360, which is angle at a point, minus 319. So we can say that will be 360 degrees minus 319 degrees, okay? So 360 minus 319, you can say we borrow 1 from this 6 remaining 5. 10 minus 9, that is 1. Then 5 minus 1, that is 4. So we have this as 41 degrees. So we can just go to that point at Q and say this is now 41 degrees. Right. This is very good. That's very interesting. So 41 and 49. What's 41 plus 49? 41 and 49. 1 plus 9 is 10, remaining 1. 4 plus 4 is 8, plus that 9 is 90. This is quite interesting now. So we can say the angle here at N is actually nothing but a right angle. A right angle here. This is angle 90. And if you can define this as angle 90, that means here we are working with nothing but a right angled triangle. Right angled triangle. I love this type of questions because our understanding of how to interpret the question is going to give us quite a whole lot of solution that we need. For a right angle triangle, we know that Pythagoras theorem, I love this. Pythagoras theorem can be used to solve for the side that we are looking for. And what is that telling us? It's telling us that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. And the longest side, or the side facing the right angle, is the hypotenuse. So here, if you want to actually represent this well, the side facing Q will be small q, so this is small q. The side facing x will be small x, so this is small x. And the side facing y will be small y, so this is small y. So from here, we can just see that this implies that q raised to power 2 is equal to x raised to power 2 plus y raised to power 2. And x we found to be 18 kilometers, y is 10 kilometers, and we're looking for q. So we can say the square of q is equal to s square will be 18 raised to power 2 plus y square will be 10 raised to power 2. And if we want to bring in our calculator to solve that, you can just say 18 raised to power 2 is what? That's 324. So this is 324 plus 10 raised to power 2 is 100. So 324 plus 100 is 424, such that q, this is q raised to power 2. So q itself will be the square root of 424. Okay, so how do you find the square root of 424? We go to our calculator and press square root of 424 is equal to what? This is 2 root 106. But I want to express it in decimal place. So this is 20.5913. So this is 20.5193. But look at the question. We're told to calculate to the nearest whole number. So we need to approximate this to a nearest whole number, meaning that we don't want any decimal place there. And for us to do that, we need to look at the number immediately following the decimal place, and that is 5. So numbers between 5 to 9 will round up to 1 and add to the initial number before it. Numbers between 0 and 4 will round down to 0 and it will not have any effect. But here it is 5. So when we round 5 up, it will become 1 and we add to 20. That will be 21 and the unit is kilometers. So 21 kilometers is the distance between cyclists X and Y. And we can just reflect on our diagram that this is here that we tag as unknown. We have now gotten it to be what? 21 kilometers. I love this question. Okay. So now we've gotten the distance between cyclists X and Y to be 21 kilometers, approximately 21 kilometers. Now we have to find the bearing of cyclist X from Y. From Y means that we need to go to Y to consider taking our cardinal point from there and look at the bearing of X from Y. So we can go to Y to take our bearing, okay? Just the 4 cardinal points that we'll be needing. Alright, so here we can just identify these to be the north, the south, the east, and the west. Okay, so the bearing of X from Y, we need to start from the north and look at it to the inclination of X to Y. So if you are looking intently, we can see that that is identified as this particular place here from the north to this angle. Okay, this is the bearing of X from Y. That particular angle, let me just call it theta. Okay, then looking at this, because if you're identifying that as theta, we need to now look at how do we get that angle theta. From what we have done before, we got this angle at Q to be 41, but we can observe that this is going to be alternate to this angle at Y, but to the south of it. I can show that with the aid of a diagram that if you take this particular angle here and you run it down to Y, okay, and then you come down south, this new angle here, this angle here, and this angle that we got initially as 41, they are alternate angles. So this will also be 41 degrees because alternate angles, they are equal. So that is 41 degrees, just like this is also 41 degrees. So if you have been able to find out to be 41 degrees, you can find a suitable means to evaluate this angle theta, because you know that angle on the straight line north to south, that's a straight line. The sum of angles on that straight line is going to be 180. Now we have 41 here. If you can find this angle at Y, okay, this angle at Y, this one in red, which is the angle corresponding to Y, okay, at that particular point of this triangle, then we can use that to sum 41 and this angle and theta, and we can equate it to 180 degrees in such a way that we can now find the value for theta. We can just say that at location Y, theta plus the angle XYQ, that's the angle at Y here, okay, plus 41 degrees that we have gotten to be alternate to this 41 from Q. The addition of the 3 is equal to 180 degrees. Why? Because they are the sum of angles on a straight line. So sum of angles on a straight line, they add up to 180 degrees, and we are leveraging on our understanding of that. So we already know 41 degrees. How do we find angle SYQ? Look at this triangle. Okay, look at this triangle. We already know the hypotenuse. We know the opposite to this angle. Opposite to this angle is 10 kilometers, which is small y. Then we also know the adjacent, which is 18 kilometers. But we are looking for this angle. So what do we want to make use of that will help us? We can make use of any of SOHCAHTOA. Okay, SOHCAHTOA is a trigonometric identity that we can use for a right angle triangle like this, in which we are looking for a particular angle while we know all the sides and we also know the right angle included. So here let's say we want to use either opposite and adjacent or anyone, but we want to relate it to this particular angle. We can say, which one do we use? We can say we want to use tan. We can say from there, tan XYQ, which is ideally opposite over adjacent, because from here, SOHCAHTOA, tan is opposite over adjacent. This is the same thing as what's the opposite? The opposite is 10 and the adjacent is 18. Students, as a rule of thumb, it's even good that we use tan, because the value that we got for the hypotenuse, you can remember, it was an approximated value. So here we have approximated it. It was actually 20.59126 or so. But we are using absolute values that were given in the question here, so our approximation can be on the right track, because at the end of the day, we are still going to find our answer to the nearest whole number. So we don't need to complicate issues for ourselves. Let's just use the values that we are given. So tan is ideal for us. So that means that tan XYQ is equal to 10 over 18. What is 10 over 18 from our calculator? 10 divided by 18 is what? It's 5 over 9, which is 0.5. This mark on top of the 5 means that it is a repeated value. So I can say it is 0.5555, then 6, since I will approximate that, such that angle XYQ is equal to arctan, I could even have said arctan 10 over 18 straight. Okay, so arctan 10 over 18, what's that? Let me, here I can say arctan, the answer I just got, that's 29.054, or I could have said directly it is arctan 10 over 18. So what's this? 29.0546. That's 29.0546. Good. But this is where we're actually going. We want to make use of that in this equation, such that we are going to have, therefore, our theta that we are looking for is going to be 180 minus the sum of this SYQ and 41, and XYQ we have gotten to be 29.0546 plus 41. Okay, when these two, when they move to the other side, they become minus. So we can subtract them from 180 to find the value of theta, which is the bearing of cyclist X from Y. Alright, so if we bring in our calculator, we can say this is 29.0546, okay, plus 41, that is equal to what? So now I can say 180 minus the answer I just got. So this is 109.9454. 109.9454. This is 109.9454. But look at the question. They told us to get it to the nearest whole number. So we need to approximate this. So, and in short, bearings are always expressed only in 3 digits. You don't put decimal place in bearings. So that means we need to knock out this particular 9. And if we take 9, we are going to round it up to 1 and add that 1 to the initial number before it, and that is 9 here. That 9 plus 1 is 10. So what we are going to have is 110. Okay, so this is approximately equal to 110 degrees. So the bearing of cyclist X from Y, here our theta is nothing but 110 degrees. All right. So here in our final question, we are asked to find the average speed at which cyclist X will get to Y in 4 hours. So when X got to here and Y is here, Y will be stationary, and then X wants to move from this particular point to Y at this point. So we have to find the speed which it needs to travel at to get to Y, but in 4 hours. If you recall, initially we said our speed is nothing but what? Is distance over time. So that's one of the things that we did immediately we are starting with this particular question. But here we are told that we have to find the speed of X to Y, okay, in 4 hours. So that time will have been given to be 4 hours. But what is the distance that we need to look at? Look at what we have here. We have 21 kilometers, but recall that this is an approximated value. Whenever you are working, don't use approximated value to solve further questions. Use the original value. Then when you get the final answer, you can approximate. But even look at this question. They didn't ask us to approximate. They just said find the average speed. So what was the original value we got for Q the other time? It was, I think, 20.59126 kilometers. But now what's the time that we are looking at? We are looking at this time that is given is now 4 hours. So the speed that x we need to take to get to y will be this 20.59126 divided by 4. So we can bring in our calculator to say we have 20.59126 divided by 4, and that is what? 5.1478. 5.1478, but now it will be kilometer per hour. This is quite long. We can just take some little approximation to take this is nothing but 5.15 kilometers per hour, because if we take 7, we will round it up to 1 and add that 1 to 4 to make 5. So the average speed at which cyclist x, this guy, will get to y, this guy, when he's there in 4 hours is nothing but 5.15 kilometers. So you have seen how we can actually solve questions on bearing and distances, how we can interpret the question as we are given, how we can use our understanding of triangles, the rules that pertain. Sometimes we get to use sine and cosine rule, but here we get to use the Pythagoras theorem and trigonometry identity, SOHCAHTOA, and we've been able to solve this question, albeit we use our understanding of the fact that speed is distance over time. So we first converted to distance to get the distances in bearing and distance, and then later we're also working with the speed again. And the more you practice with this type of question, the better you are going to be. You can check our playlist. We have quite a number of questions on bearing and distances, angle of elevation and depression, triangles in general, and you can make use of them to build your proficiency in this type of questions. All right. This question is a question featuring the cumulative frequency curve, popularly called Ogive, and in the question, we're told that the table shows the distribution of marks obtained by students in an examination. So we have those marks and the associated frequencies with each set of the marks, and then we're told to construct first a cumulative frequency table for the distribution, and then we're to draw the cumulative frequency curve for the distribution, and then using the curve we are to find correct to one decimal place, the median mark, and the lowest mark for distinction if only 5% of the students passed with distinction. So this is the question, and we are going to go ahead to attempt them correctly. In this particular year, students, you just need to take notes. You cannot run away from questions on graph. This is the second question on graph, and so let's put our minds together. If you can get your pen, your biro, your graph sheet, let's work this together so that once you know how to do this, you'll be able to replicate it in your exams, and that excellence you are going to gain. So we are going to come up with a table right about now. So this is going to be the solution to the question on the cumulative frequency curve. Okay, so first we are asked to find the cumulative frequency table, and that's what we are going to be coming up with here. And the feature of the table is that we have our marks as we are given, we have the frequency which we are also given, but we are going to compute the upper class boundary, the UCB, and the cumulative frequency. And this is the way to go about it. Now, to get the upper class boundary, we need to look at the higher mark in the first set, okay, and the lower mark in the second set, and find the average of the two. Here we have 9 and 10, meaning that we will just say the upper class boundary for the first case will be 9 plus 10 divided by 2. 9 plus 10 is 19, so we have 19 over 2, and 19 over 2 is 9.5. So that's how we are going to compute the upper class boundary for each of the class. The upper class boundary in this particular case is going to be 9.5. So we just put that in as 9.5, and the same incremental value will just happen to these higher marks for each mark set. So we have in this case, we have 19.5 and then 29.5 and 39.5 and on like that. All right. So let me just fill this up. So this is the set of values for the upper class boundary. You don't need the lower class boundary, okay? You just need the upper class boundary to compute the table for the cumulative frequency table and use subsequently in the cumulative frequency graph, okay? Now, how do we get the cumulative frequency? For the first set of marks, the cumulative frequency will also be the frequency. So here we have 7. But for subsequent ones, we are going to add the initial cumulative frequency to the next frequency. So here, the cumulative frequency initially is 7. Then plus this frequency, 7 plus 11, that will be 18, okay? Then here, it will be 18 plus 17. So that's why you call it cumulative. You continue to add each subsequent frequency to the initial cumulative that we have gotten before. So 18 plus 17, that should be 35, okay? Then we have 35 plus 20, that will be 55. 55 plus 29, 9 and 5, that is 14. 2 and 5 is 7 plus 1, this is 84, okay? 84 plus 34, 4 plus 4 is 8. 8 plus 3, that is 11, okay? 118 plus 30, that will be 148. 148 plus 25, 8 plus 5, that is 13. Okay, 4 plus 2 is 6, plus that 1, that will be 7, and I have 1 here. 173 plus 21 will be 194, and 194 plus 6 will be 200. So, now that we got the final cumulative frequency to be 200, you need to check so that you don't make mistakes. So, to check, what you do is you add by the use of the calculator, okay? You add each of these entries of frequencies together, and you have to ensure that the sum you get here and this final cumulative frequency you get, they are going to be the same. So, if you want to do that, you can just say here we have 7 plus 11 plus 17 plus 20 plus 29 plus 34 plus 30 plus 25 plus 21 and plus 6. What's the sum of that? Good. That is 200. So we're on the right track. We've been able to compute all the cumulative frequencies as needed for this particular cumulative frequency table. And then in the second question, we are told to plot the cumulative frequency curve. That is the Ogive. So we are going to go ahead to look at how to do that now. So we have our graph sheet here. Now in plotting the cumulative frequency curve, what we do is that we have the cumulative frequency on the vertical axis and the upper class boundary on the horizontal axis. That's the ideal way to go about plotting the particular graph. And if you look at this, here we have our least value to be 7 and then the highest value to be 200. So we need to scale this vertical axis in such a way that 7 up to 200 are appropriately catered for. And if you look at the number of boxes that I have in this particular graph, you also need to confirm with your graph sheet that is supplied to you in the exam. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 12 divisions. Let's say I want to leave the margin at the lower space and at the upper space. So I can say I have 10 divisions. I have 200 as the highest mark. So how do I divide 200 in 10 positions? I can just say 200 over 10 and that will be 20. So each of these big box, which is generally taken as 2 centimeters, for me should represent 20 units on the cumulative frequency scale. Okay, so if I have that, look at the upper class boundary. This is on cumulative frequency. On the upper class boundary axis, I have 9.5 down to 99.5, and there are incremental values of 10, 9.5, 19.5, 29.5. Then I don't need to really start from the origin. Okay, that's not necessary here. I will just say that for that particular horizontal axis, then my scale should be 2 centimeters to represent 10 marks on the upper class boundary axis. So this is going to be the scale that I'll be using for this particular question. So I can say I have my scale as 2 centimeters representing 20 units on the cumulative frequency axis and 2 centimeters representing 10 marks on the upper class boundary axis. Now, we want to divide our graph in such a way to cater for all of this. We only have positive values to the horizontal and positive values to the vertical in both cases. So what we need to just do is that we need to make them meet. I think this will be a good position so I can draw my horizontal graph just like this. That's the horizontal axis, and then can also cater for the vertical axis just like that. All right, so that is as good as it gets. And then because the upper class boundary is not on a scale of 10, okay, normally what I advise students to do is you can notch that origin, showing that you are not really scaling from the origin. Then you can use these thick lines, okay, the 2 centimeters to represent your 10. Okay, you know the space from each 2 centimeter mark is 10 marks, but because I've notched it, I'm not starting from 0. So I want to say I'm starting this from 9.5. okay, so this will be 19.5, this will be 29.5, this will be 39.5, then 49.5, 59.5, then 69.5, 79.5, 89.5, and 99.5. And you can see it scale appropriately. So I don't need to be saying that it's 9.5 that is in between these last two. No, because I'm not starting from the origin, I notched it and then I can mark it off in incremental values of 10, but starting from 9.5. Now, on the vertical axis, I've said that I have 200 and I'm using some divisions of 20. Okay, so here in this first case, this will be 20 and this will be 40, this will be 60, 80, 100, 120, incremental values of 20, okay, 140, 160, 180, and here is 200. Okay, so that's how that's going to be. We are now having all our values I want to represent correctly denoted in this particular graph sheet, and we can say we want to go ahead to start extrapolating those values against one another. So here I've appropriately labeled my scale of the graph. I have my axis, the horizontal axis and the vertical axis. I have my cumulative frequency table. I just need to extrapolate those values as appropriate, and this is what I would love to do. Now, on the cumulative frequency axis, already I'm saying 2 centimeters. Each of these tick box is representing 20 units. So here on my graph, I have 5 divisions. So I can say 5 is corresponding to 20 units. Okay. So how much value is just a box going to take? I can call that M. To find the value of that singular small box, I will just cross multiply to say 5M is equal to 20, so that if I divide both sides by 5, my M is going to be 20 over 5, that is 4. Okay, so each of these small boxes that I'm having is going to take 4. This is the classical way that you can use to find how to extrapolate your values on the graph without any stress. Like here, I have 5 divisions, no problem. In your graph paper, on your graph sheet, you may have 10 divisions, so you can say 10 is equal to 20 units. So how much unit is 1 going to take? Of course, that's going to be 2. Or just like in this second case now, you can see on the upper class boundary axis, I'm just showing this so that you can understand perfectly how to construct your graph and go ahead without having any headache. Already we are saying that 2 centimeters, which is actually the division here, is corresponding to 10 marks. So on my graph, what I have is 5 subdivisions. So those 5 subdivisions is equivalent to 10 marks. Okay, And then what's 1 mark going to be? If I call that n, again I cross multiply. I will just like I did there, n will be 10 over 5, and that is 2 marks. But I don't even need that, because on this particular axis, all of the extrapolations I want to do will land directly on the tick boxes. That is why I was recommending that you need to notch so that your 9.5 don't fall here. They just fall directly on the tick line. So we are good to go. We have our subdivisions. We know what to do. We can go ahead to extrapolate those values. So let me just clear my board here. And then good enough, we can look at the first case. When the upper class boundary is 9.5, we know this is 9.5. So we are tracing from 9.5 here. And we're trying to get the corresponding values on the vertical axis, okay, the cumulative frequency axis. Here we have 7, but we already know that this is 4, this is 8, 12, 16, and 20. So that is consistent. So 7 will be just before 8. Just before 8, if I want to just do that, I will say it's just somewhere around here. And if that's the case, we can just try and join them together just like this. And you can see that point of intersection is the point of interest for us. So I don't want to make my graph clumsy. I just want students to see what I'm doing. So I'm noting that here is my point of interest. In the second case, we have 19.5 and 18. This is 20. Just before it is 16. So in between the two is 18. So I will just have my 18 here. I think this will be more beautiful for you if you are having subdivisions of 10 units on the graph. You'll just be able to locate your values appropriately. But no problem, we can go ahead with what we have here too. When the upper class boundary is 29.5, we have the cumulative frequency to be 35. Okay, so here, this is 20, 24, 28, 32, 36, and 40. So 35 will be somewhere here. Just extrapolating with 29.5. Then for 39.5, we have 55. 55, look at what I want to do now. This is 40, okay? Here is 40 on this line. This is 40. Here is 60. 50 will be in between them, like this. Then 55 will be in between 60 and 50. So it should be somewhere here. And that's what I will trace here to extrapolate to it, 39.5. It will be somewhere here. And you can see how I'm even managing my graph, despite the fact that I have quite small divisions to use. It's just for you to build your proficiency in knowing what to go about, how to go about solving this also. So 49.5 and 84. So here we have 80, and the next one is just 84 because we are using 4 as our sub-graph division. So that's quite clear. Then we have 59.5 and 118. Now it's getting interesting. 118, if you take 4 out of 120, that will be 116 here. So 118 will be just in between those two. Alright, okay. Then 69.5, 69.5 and 148. This is 140, 144, 148. I hope you are getting this quite easily, okay. The more you practice with this, I can assure you the better you are going to become. You can check some of the videos we've done before. It's not as vast and quick as this, but practice is now getting us better on working questions like this. So when the upper class boundary is 79.5, okay, the cumulative frequency is 173. So here we have 79.5 on this line. So we have 160, 164, 168, 172, and we're looking at 173. So it's just very close here. All right. And then when we have 89.5 on the upper class boundary, we have 194 on the cumulative frequency. 194, this is 180, 184, 188, 192, 196. So just here is 194. and then 299.5. This is the simplest that you can do. And so we have our points that we can now try and join together to form our cumulative frequency curve. So that's what I'm going to do now. Students, you can make use of your French curve. For the cumulative frequency curve, the French curve is quite versatile for you. It's just a matter of you trying to locate all the points together and joining them as appropriate. But I'm going to employ freehand there because I'm using my digital tool and I can't bring in a French curve. So let's see how that goes. So here is my cumulative frequency curve, popularly called the Ogive. On your graph sheet, just appropriately label it as the cumulative frequency curve, okay? So that is as good as done. So the other thing that we're asked to find in question C is that in the first case, we're asked to find the median mark. How do you find the median mark given this cumulative frequency curve? This is what we do. Look at the cumulative frequency that we got finally. It's 200, okay? So we have the median mark will be at the 200/2 position. Okay? And that will be the 100th term. Okay? So we are looking for the 100th term. 200/2 is 100. So here we can see this is our 100. And I can just come over to my graph. On the cumulative frequency graph, this is 100 here, this is 100, and then I want to trace from 100 to the curve. Oh, beautiful. Okay, then from there, I want to trace down to see what my mark is going to be, and here it is. Just particularly at this location, you can see. So the question is, what mark is corresponding to that on the upper class boundary axis? You can see from the graph that is going to give, it is exactly in the midpoint of 49.5 and 59.5. Okay, so, or if I want to just take my normal division that I extrapolated before, I will say there are subdivisions of 2 marks. So I have 49.5 here plus 2, that will be 51.5, plus another 2, that will be 53.5. If I want to add another 2, that will now be 55.5. So I have 53.5, I have 55.5. What is the middle of that? And that will be 54.5 marks. Okay. Normally there will be a margin for error in the exam, so they may add plus or minus 1 mark, but for this particular question, we can see that we are quite on point. It is 54.5 marks. So this is corresponding to the first question in number C. Okay, now we need to look at the second question in C, in which we are told that if 5% of the students add distinction, so 5% add distinctions, then we are to look at the least mark for distinction. Now, this is what we need to do. If 5% add distinction, that means that 95%, that's 95/100 of 200 is going to be the least mark for distinction. And like this, you can just cut 100 here 1, 100 here 2. So 95 times 2, that is the 198th term. So it is the 198th term that will correspond to the least mark for a student to get to earn distinction in the result for the marks that we are collating. So we need to look at the 198th term, and if you look at this curve now, this Ogive curve, this is 180, this is 200. In between them will be exactly 190 because it's the median of the two. So we have 190 here, but we are looking for the scenario in which we trace this 198th term to the curve and then find the mark on the upper class boundary axis. So we can just trace like this from 190, just take it to the curve, ensure that is a straight line. I don't want to miss that. Okay, and then from whatever it is that we are looking at, we can just just ensuring we have our straight line. Student, you can make use of your ruler to find this correctly, and you can see this is quite good. So we are looking at this position, that is the value of the mark that we are concerned about. Now look at this. Initially we have identified that each of the small divisions of my box is taking 2 marks. So here, this is just the box immediately before the 89.5 mark. So just taking 2 marks out of that will amount to 87.5. So this is going to give me, this one was 54.5 marks. This is going to give me 87.5 as a mark for distinction. Okay, you can just take a margin of error for plus or minus 1, but 87.5 will be the least mark for distinction in this particular set of data that we are given for the marks scored by students in the test. And like that, we have come to the end of this beautiful question on cumulative frequency curve, in which first we evaluated the cumulative frequency table, we found the upper class boundary, we evaluated the cumulative frequency, and we used those data to plot the graph of the cumulative frequency curve, that is the Ogive, just as it was shown here. And then we're able to use the curve to find the median mark, which amount to half of the total cumulative frequency, that's half of 200, which is the 100th term, and we found the corresponding mark for the 100th term to be 54.5 marks. And then we were able to find the least mark for distinction if 5% of them are distinction. The 5% will amount to 190 to 200. This region here, this region at the top of the curve, that's the distinction. So the least mark, we just trace it to the upper class boundary as is to get the least mark for distinction as 87.5 marks. So this is just the process that you need to follow as student to be able to work with cumulative frequency curve, the Ogive curve, the cumulative frequency table. And the admonition we always give is that the more you practice with this, the better you are going to become. Okay, so just take your pencil, take your graph sheet, take your workbook, go through your past questions, look at all the years in which you are seeing questions that are featuring the cumulative frequency table or the cumulative frequency curve, and make sure you attempt them, and you will see that to be better prepared for your exam to gain. In this question on circle theorems, we are told that in the diagram, MNPQ, this MNPQ is defining a circle with center O, and then line MN is equal to line NP. So this is MN and this is NP. You can see they are being notched together. Okay, both of them are notched to show that they are of the same length. And then angle OMN is 50 degrees. Here OMN is 50 degrees. We are asked to find angle MNP and angle POQ. So in the first case, we are asked to find angle MNP. So what we are looking for is angle MNP. And if you look at the diagram, MNP, so this is the angle in question. Let me just show that in red. This is the angle in question, and I can call that angle X. So I can say my MNP is equal to X from the diagram. Okay, and then how do we go about solving this particular question to find the value of X? This is where we need to bring in our ingenuity and understanding of circle theorems and every other practical laws that we can bring into play to solve this question. Now, looking at the question originally, we are told that MNPQ is a circle with center O, but that's not the only thing we can say about MNPQ. If we are not defining MNPQ along the path of the circumference, we can also define it along these straight lines in which we are having a polygon with 4 sides, and that is forming a cyclic quadrilateral. What's the meaning of that? That means a polygon with 4 sides that is inscribed in a circle, so we call it a cyclic quadrilateral. And if I want to just show that, I will just start from M again. We have M, N, P, and Q. You can see that's the third side, and then here we are having the fourth side. So that is a cyclic quadrilateral, and there is a property that we are going to make use of, that the opposite angles of cyclic quadrilateral are supplementary. So we need to note this: opposite angles of cyclic quadrilateral are supplementary. I'm just writing this in short notes. I know you'll be able to follow through. So if you are to apply this particular theorem, how do we go about applying it in this particular case? We need to identify the opposite angles of this cyclic quadrilateral. It has 4 sides, 1, 2, 3, 4. So what is the side facing this particular 50 degrees angle? It is this particular angle. Okay, so we can say angle QMN plus the angle opposite it, that is angle QPN, both of them add up to 180 degrees. Okay, and in the same vein, look at the angle we are looking for, MNP, which is X. Let me just write it as angle MNP plus the other angle MQP. They also add up to 180 degrees, following this particular postulate that opposite angles of cyclic quadrilateral are supplementary. Okay, so that's the first thing I want us to note. The second case, look at this. Just take a look at this. The diameter of the circle, from what we are looking at in the diagram, happens to be the line MQ. So we are told that O is the center of the circle, and you can see this is a straight line starting from one end of the circumference, passing through the center and going to the other end of the circumference. So that is the diameter of this particular circle. But we're also seeing that that diameter is subtending an angle at P. Okay, so from M to Q, you can see MPQ, in which MQ is the diameter. And there's another theorem for the circle that we are told that the angle, angle subtended at the circumference of a circle by diameter is a right angle, is 90 degrees. That's what it means by is a right angle. The angle subtended by the diameter of a circle at the circumference is a right angle, it is 90 degrees. That means that what we have here is this angle is going to give us 90 degrees. Okay, that is this other postulate that is giving us that information. Okay, then in the question we are told that line MN is equal to line NP. So MN here and NP, they are equal. And what is the implication on that? From the triangle MNP, we can see that this particular angle and this particular angle, they are going to be equal. So if I call this A, this will also be A. Why? Because they are base angles of an isosceles triangle. Isosceles because two of its sides are equal, and then the base angles are also going to be equal. So I can say this is A, this is A. I can say angle NMP is equal to angle NPM, and that is A. I denoted that as A. Alright. And then all of these, how are they going to help me to solve this particular question? I know that this is angle 90 degrees now. Alright. And I know that the sum of this angle 50 here and this angle, they are going to be supplementary. They will add up to 180 degrees. That will allow me to find the angle A. If I know this particular angle A, I can actually use this particular triangle that I said is isosceles to sum the angles of this triangle, which I also know to be 180 degrees. And since I know A, I can find this A also. Of course, both of them are A. I can add 2A to X to equate them to 180 degrees to solve for the value of X. That's why I'm actually postulating all of this. And from what I've been saying all along, that means that I can say QMN, angle QMN plus angle QPN, which are opposite angles of the cyclic quadrilateral. They add up to 180 degrees. Now, what is QMN? QMN will be given to be 50 plus QPN. Now, look at QPN. QPN happens to be this 90 plus this A. That's the beauty of what we need to actually apply here. 90 plus A, which is QPN. QPN. It is this right angle, this 90 degrees, plus this particular A here. So the sum of the three is 180 degrees, such that A will be 180 minus 50 plus 90 is 140. So A is nothing but 40 degrees. Good and interesting. So I have my A to be 40 degrees. I can now look at this triangle MNP to say from triangle MNP, I know that the sum of angles of a triangle is 180 degrees. So I can say the sum of angles is going to give me 180 degrees. And summing the angles, I can say that means that x plus A, you can see x, A, and A, they are the angles of the triangle MNP. The three of them is 180 degrees. And in that case, x will be 180 degrees minus 2A, because A plus A is 2A. And that is going to give me my solution that x is equal to 180 degrees minus the value of A that we got was what? Was 40. So x is 180 minus 2 times 40 is 80, and 180 minus 80 is 100 degrees. So the value of x, which is angle MNP that we're asked to find, is nothing but 100 degrees. And you can see how we're able to find it, because we look at the cyclic, quadrilateral, and we also look at the isosceles triangle, and then we look at the fact that the angle subtended by a diameter at the circumference of the circle is a right angle. And bringing these three together, we're able to postulate and apply the applications of these theorems to get the solution to angle MNP as 100 degrees. So we can now move on to angle POQ. Okay. So in this second question, we are to look for angle POQ. Okay. And POQ, where is POQ? This is POQ. Is this angle here that we are looking for now? Let me call that angle Y. So I can say it's angle Y. Alright, so that I will not be confused just writing POQ and POQ. Now there are quite a number of ways that we can apply to solve for this particular question. But first, let's just identify some other things. Looking at this triangle, we can notice that here, from the center of the circle to any point of the circumference, any straight line drawn from the center of the circle to any point on the circumference is going to constitute the radius of the circle. So this line OQ is the radius. This line OP is also another radius. Okay, so OQ and OP constitute the radius of the triangle. Okay, this triangle OQP. And if that is the case, then I can know that the base angles of this triangle are also going to be equal. So this angle here, this angle, if I call this B, then this angle here, it's also going to be B. Why am I saying that? Because they are the base angles of this isosceles triangle. So I can just state that out, that angle OQP is equal to angle OPQ, and I'm denoting that as B, and I'm calling them the base angles of isosceles triangle OPQ. Okay, they are the base angles of the isosceles triangle OPQ. But you recall that we have gotten the value of x to be 100 degrees. Now, MNP, just look at this now. Angle MNP plus angle MQP, if you are observant, we will see that they are also opposite each other. This is the cyclic quadrilateral. So MNP, this x, and MQP, this b, they will add up to 180 degrees because they are supplementary. So MNP is x, so this is x, plus MQP is b, and the sum of the two is 180 degrees. So our b will be 180 minus x. And from our previous question, we have gotten x to be 100. So angle B is 180 degrees minus 100 degrees, and that is nothing but 80 degrees. So B here is 80 degrees, but looking at the triangle OQP, but from triangle OQP, we can sum the angles in that triangle to say Y plus B is equal to 180 degrees. Why am I saying that? Y, B, and B, they are the angles in that particular triangle. And we know that the sum of angles of a triangle is 180 degrees. So Y will be 180 minus 2B. And that is nothing but 180 minus 2 times 80. And that will be 180 minus 2 times 80 is 160 degrees. So Y, which is the angle POQ that we are looking for, is nothing but 180 minus 160 is 20 degrees. Now, this is what I want you to note. Students, there are so many ways you could have gone ahead to solve these questions. It just depends on your ingenuity of how to identify the theorems that you need to use. So I could have said, here, this angle here is going to be 2x because it is going to be twice the angle subtended at the circumference that we have at the center. But look at something. Both of them are facing the same side. X is facing here, and here in the middle is also facing here. Okay, so this is 2x, and 2x is going to be 200. All right. Now, that 200 that we just got, we can see that it is the angle on the straight line, MQ, which is 180, that is adding to this y plus y that is giving us this particular 200 degrees that we got as 2x. And if that is the case, you can say that y is nothing but 200 minus 180. And look at it. Is that not the same answer? Of course, that is also going to give us 20 degrees. So there are just so many ways. You just need to master all the theorems of the circle theorems. Then you need to understand the cyclic quadrilateral. You need to understand the properties of an isosceles triangle, and you'll be able to solve questions like this. There is no particular single way to solve it. There are just many ways. This is just another method I showed. There are so many other ways I could have chosen to say, no, I also want to apply this. But the thing is that you need to practice. The more you practice, the better you become. And that's why you should just check our playlist to develop your proficiency in solving questions like this. And then you'll be able to dust them in an exam and gain that excellence. All right? Here in this question, the equation of a line, we are asked to find the equation of the line, which has the same gradient as 8y plus 4x is equal to 24, and the line also passes through the point minus 8, 12. So the understanding that we need to have to try and solve this type of question is to know that whenever we are talking about two lines in which we are looking at them to have the same gradient, like here, we are told that it has the same gradient as 8y plus 4x is equal to 24. So we can have a pictorial view of something like this. If you have our Cartesian plane and we are looking at the vertical axis and the horizontal axis, if you have defined a first line to say this like a particular first line, if we define it as y1 is equal to mx1 plus c1, in which here c is the intercept and this is the y-axis and here is the x-axis. But now we are being told that this particular line, just like we are given in this equation, has the same gradient with another line, but we are not told that that other line passes through a particular point like minus 8, 12. Now this is what we are going to have. That means both of those lines, like the first one we are given and the other one that we have just like this, you can see it means that if this is the second one and we have it like y2 is equals to mx2 plus c2, in which here this is also the intercept, that's c for the second one, and we have the x-axis and the y-axis. The thing common to the two of them is that for them to share the same gradient, then the slope of the first one is equal to the slope of the second one. So m1 is equal to m2 for them to have the same gradient. So once we have this particular understanding, it will make our work easy, because what we now need to do is that from the first equation we can find the slope, by writing it in the order y is equal to mx plus c. And then, since we know the point that we are given for the second equation, we just interpolate those points with y and x and use the gradient that we have gotten for the first one. So for this particular question, we are given that 8y plus 4x is equal to 24. But we want to look at a means in which we can arrange like y is equal to mx plus c. And we can say this means that 8y is equal to minus 4x plus 24. And that is obtained by moving 4x to the right hand side. And now we can see that if we want it to be y is equal to mx plus c, we should divide this equation by 8. The left hand side and the right hand side, each of the entities, in fact, we can divide by 8. And if we do that, we are going to have something like this. 8y over 8 will be y, okay, is equal to minus 4 over 8x plus 24 over 8. In short, let me just put the first one also as, this is also 8y over 8. We are dividing each of the entry by 8. Therefore, what we have is that this 8 and 8 will cut. So we have y is equal to minus 4 over 8 is the same as minus 1 over 2x. Then 24 over 8 is 3. So this is the alternate representation of this equation that we have here. Instead of writing 8y plus 4x is equal to 24, we can write it as y is equal to minus 1 over 2x plus 3. Why did we do this? Because we want it to look like y is equal to mx plus c. And you can see from here, what are we noticing? We are noticing that this means that our m is equal to minus 1 over 2. And this is what we need to use for the other equation. That's why we are trying effortlessly to make sure that we express it in the form y is equal to mx plus c. So having done that, we can now look at the means by which we can get this other equation that is passing through the point minus 8, 12. So what I want to make use of is this general equation that the change in y is equal to m multiplied by the change in x. And what's the meaning of this? This implies that y minus y1 is equal to m multiplied by x minus x1. So what is my y1? What is my x1? It is the same as what we are giving here. This that we are giving is the same as x1 comma y1. So x1 is minus 8, y1 is 12. So here, if you want to plug in those values as appropriate, you can just say this is now going to give us y minus, our y1 is 12, so we have 12 is equal to, what's the value for our m, the gradient? That is minus 1 over 2 multiplied by x minus x1, and that x1 is not 8, it is minus 8, so we need to put it appropriately as minus 8. And this will mean that we have y minus 12 is equal to minus 1 over 2 multiplied by x. When we say minus 8, it's like we are multiplying two negative numbers, okay? And the product of two negative numbers is a positive number, so we have this to be plus 8, okay? So having done that, what we can also do is we can cross multiply these two at the numerator. These two at the denominator can be used to multiply the whole left hand side. So we are going to have something like 2 into y minus 12 is equal to minus 1 multiplied by x plus 8. So again, if you expand that bracket, you can see 2 times y will be 2y, 2 times minus 12 will be minus 24 is equal to minus 1 times x is minus x, minus 1 times 8 is minus 8. Okay, so now we want to just leave y on the left hand side and take the other number, this minus 24, to the right hand side. So we are going to have 2y is equal to minus x minus 8, but now it will be plus 24 because initially it was negative. When it moves to the right hand side, it will become positive, and that is the same thing as saying 2y is equal to minus x minus 8 plus 24 is plus 16. I want to write it in such a way that we will express it just like we expressed the first one, and to do that we can just divide each of the entry by 2, and if we do that, that means what we are going to have is that here these two can cancel, so we have y is equal to minus x over 2 is the same as minus 1 over 2x, okay? Then 16 over 2 is 8. And like this, we've been able to solve this particular question correctly. And you can see, look at the two equations. Here we have the slope to be minus half, and here the slope is also minus half. It's only the intercept that is changing. In the first case, the intercept is 3, but here the intercept is 8. So this is how to go about solving our question, and the correct solution is y is equal to minus half x plus 8. In this question on circle theorems, we are told that in the diagram, line AB, this line AB, is a tangent to the circle with center O. So this circle with center O has line AB as its tangent, and COB is a straight line. So this is COB, that's a straight line. If line CD is parallel to line AB, so CD here is parallel to this line AB, and angle ABE, that angle is 40 degrees. We are to find angle ODE. So let's try and locate that. This will be the angle ODE here. We can call it X, okay? That's the angle that we're asked to find. Now, how do we go about trying to solve this particular question? Looking at all that we are given, we need to bring in the ingenuity of our understanding of parallel lines, intercept theorem, circle theorems, and triangles to try and solve this particular question. And the first thing I would like to look at is, look at this line COD. The line COB that we're given is a straight line, means that line COE is the diameter of the circle. So if COE is the diameter of the circle, the angle that the diameter of the circle subtend at the circumference, this angle CDE, is going to be 90 degrees. So this here, this angle here, this is going to be a right angle. So I can say from my diagram, the angle CDE is going to be a right angle. Why? It is the angle subtended by the diameter at the circumference. Angle subtended by the diameter at the circumference. That's the reason by which I can postulate that this is nothing but 90 degrees. So it's the understanding of circle theorems that is allowing me to make that postulate. Now, if that is the case, I can look at this particular triangle ODE. If I look at the triangle ODE, from here I can see that, look at this, the center of the circle. From O to E, this is the radius of the circle. From O to D, this is another radius of the circle. So, meaning that this angle here, I can also render it as x. Why? Because they are the base angles of an isosceles triangle. Why am I saying isosceles triangle? Is because this triangle ODE has two of its sides to be equal, and so it inherently have the base angles to be equal. That is a property for the isosceles triangle. So I can say angle ODE is also equal to angle OED, and I've tagged it as x, and because they are base angles of isosceles triangle, base angles of an isosceles triangle, a triangle that has two of its sides equal, and therefore it also have the base angles equal. Okay, finally, I think we just need one more thing and we'll be able to solve this particular question. Look at this particular diagram here. If we consider, we are told that the line AB and the line CD, they are parallel to each other. So we can look at the transversal running across the line AB and line CB, and this is the transversal, it is the line COEB. If I go to this line AB and draw this particular straight line, and I also go to C, okay, and I also come here, I can see readily that this angle here that we're given to be 40, and this angle, they are going to be equal. So this is also going to be 40, meaning that I can say the angle ABE that we're given is also equal to angle BCD, and the value is 40 degrees. And why? Is because they are alternate angles. That's another property of parallel lines in which we have a transversal running across the two of them. So with these three postulates that we have already, how can we make use of that to solve for the value of x, which happens to be the value of the angle ODE that we are looking for? This is what I want to look. Just look at this. Consider the triangle CDE. We can see that we have three angles there. Here we have 40. Here we have 90 degrees. This is a right angle. And here we have x. We can say 40 degrees plus 90 degrees plus x is equal to 180 degrees. And why are we saying that? Is because they are the sum of angles of a triangle. And we know that the sum of angles of a triangle, they always add up to 180 degrees. And in that case, if we are to solve for x, x will be 180 minus the sum of 40 and 90. Now, 40 and 90 will give us 130. So x will be 180 minus 130, and that is 50 degrees. And therefore, the angle that we are looking for, which from our postulate we've been able to say that angle ODE is equal to x, you can say angle ODE, we said it was x, and the value is nothing but 50 degrees. And you can see how our understanding of parallel lines and the transversal running across them can help us to generate alternate angles. How the fact that the line or the diameter of a circle subtends a right angle at the circumference here at D, and finally the sum of angles of a triangle adding up to 180 degrees. All these postulates, you can see how they have helped us to evaluate the correct solution to this question, that angle OD that we're asked to find is nothing but 50 degrees. All right. In this question on mensuration of shapes, we're told that ABCD is a parallelogram in which the line CD is 7 centimeters, the line AD is 5 centimeters, and the angle ADC is 125 degrees. First, we have to illustrate the information in a diagram. I think this is a bit for the examiners to actually ensure that students have some good understanding of how to construct, because this is as good as a question which are being asked to construct. But how do we go about solving this particular type of question? First, we need to understand what we are being asked. Here, we are being told that we are working with a parallelogram, all right? So, what is our understanding of how a parallelogram looks? A parallelogram actually has its four sides being parallel 2 by 2 to one another. So this line and this line will be parallel, and this line and this line will also be parallel, all right? But here in the question, we are told that, look at this, the line CD is 7 centimeters, AD is 5 centimeters, ADC is 125 degrees. As a rule of thumb, even if you look at this and you consider this particular diagram, you can see that the angle that will be greater than 90 is either this one or this one. Any of the two will be suitable for you, okay? So for me, I think I want to pick here. So that means that I will have something like this. I just want to do a rough, in which if this is the 125 degrees, ADC means that is the midpoint here. This is D that we are taking the angle. Then we are told that AD is 5 centimeters and CD is 7 centimeters. Between these two, which one is longer? You can see that this is the longer one. So this will have to be CD, and this will be 7 centimeters. And here will have to be A, so that this is AD, and this will be 5 centimeters. So is the understanding of knowing how a parallelogram looks that will enable you to solve this question wonderfully and correctly. Like here, since I now know this is AD, this is CD, of course the last vertex will have to be B. So I've drawn my parallelogram ABCD as requested. So this is my rough. I'm still going to construct it correctly, and I can just say I want to clear the board, and now I can just correctly represent the diagram just like this. I have this line, I have this line, I have this line, just some pictorial view or something at least that will make sense, and we need to show that this line is parallel to this line, and this line is parallel to this line. I got this to be D, in which Here is angle 125 degrees. This is A, so that AD is 5 centimeters, and then this is C, so that CD is 7 centimeters, and finally the last vertex is B. So this is the first solution that we're asked to find, that will illustrate the information in a diagram. Now we are to find correct to one decimal place the area of these parallelograms. And what is the formula for the area of a parallelogram? The area of a parallelogram is given by the product of the base multiplied by the perpendicular height. Okay, so this height is not this slant height. We need to look for a means to find the perpendicular height here. Okay, and that perpendicular height, by reason of its definition, it has to be at right angle to the base, and so this is the h that we need to multiply by. In this particular case, 7 centimeters is the base. So how do you find the value for the height? That's the first task that is also confronting us like this. Now there are two particular ways. We can actually evaluate it from here to try and find this particular angle and then sort it out, or we can actually bring it here, which is what I want to do. I can just say here, this is also going to be my height. Okay, and I want to show you just a beautiful symmetry that is going to be here. Now this angle at D we're given to be 125, but already I'm saying that I'm looking for a right angle here. So if I take 90, which is a right angle, out of 125, this is going to remain 35. Okay, so looking at this particular shape, if I call this O, I can say from triangle ODA, which is something that I have like this. Okay, so this is also 90, and this is 35, this is H, and this is 5. Now this is the angle that I'm considering at D is 35. This is O, this is A. This 5 will happen to be the hypotenuse, okay, because it's the side facing the right angle and it's also the longest side, and then H is the adjacent. So my question is, what is the formula that is relating the adjacent and the hypotenuse for a right angle triangle? Recall, we are actually going to make use of SOHCAHTOA. So we are looking for what is relating the adjacent and the hypotenuse, and you can see it is cos. So from here I can say cos 35, which is nothing but adjacent over hypotenuse, is going to give me the adjacent is h that we are looking for, and the hypotenuse is 5, such that h will be 5 cos 35 degrees. And if I bring in my calculator to evaluate that, I can say 5 cos 35. What is that going to give me? 4.09576 or 4.096. So this is 4.096 centimeters. All right, but nobody asks us to find the height. We actually asked to find the area. So since I now know the height, I can say the area of the parallelogram is the base, which is 7 centimeters, multiplied by the height, which is 4.096 centimeters. And if I'm going to evaluate that, I can say that's the last answer that I just got, multiplied by 7, and that's going to give me 28.67. That's 28.67 centimeters square. But look at what we're asked to find. We're asked to find correct to one decimal place. So this is approximately equal to, if we want to put this to one decimal place, that means only one number, only one digit will reflect after the decimal place. So we'll take 7 and round it up. Numbers between from 0 to 4 are rounded down to 0, but from 5 to 9 they are rounded up to 1 and added to the initial number. So 7 will be rounded up to 1, and when we add down 1 to 6, this is becomes 7. So we have 28.7 centimeters square as the area of the parallelogram that we are given here. So alternatively, we could have said that looking at this particular h in blue, we can say that 125 plus this angle here, if I call this theta, the two of them, they are actually supplementary. They will add up to 180 degrees. So this will be 180 minus 125, so it will be 55. Then we can also use SOHCAHTOA to find, because this is also 5, this is 5 centimeter, and now we have the hypotenuse, which is 5 centimeter, and we are looking for the opposite. So instead of using cos, we will now be using of sine, which is opposite over hypotenuse, and we'll still find the value of h to be 4.096, and then we can multiply the areas to be 7 times 4.096 and still arrive at the same answer as 28.7 centimeters square. All right. Yeah, in this question on algebra processes on SORD, we are told that if x is 1 over 2 multiplied by 1 minus root 2, we are to evaluate 2x squared minus 2x. So we can just go ahead directly and put in the value for x into this particular expression and open our bracket and solve algebraic wise to see what the solution is going to give us. So we can say, given that x is equal to 1 over 2 multiplied by 1 minus root 2, okay, we want to find 2x squared minus 2x, but I can even say, okay, maybe s is common. Let's just substitute the values of s and see what we're going to get here. So that will be 2 multiplied by x squared will now be 1 over 2 multiplied by 1 minus root 2. All of this raised to power 2 because this is x, then minus 2 multiplied by 1 over 2 of 1 minus root 2. Alright, so if I were to try and solve this, these two I'm still writing. The square of this, 1 over 2 raised to power 2 will become 1 over 4, okay? Then 1 minus root 2 raised to power 2 will be 1 minus root 2 multiplied by 1 minus root 2, okay? So then that's the first entry, minus these two and these two can cut themselves, so we still have only 1 minus root 2 remaining for this second expression. All right, so here I can just say this 2 here 1, this 2 in 4 is 2. So what I'm having is 1 over 2 multiplying the product of 1 minus root 2 times 1 minus root 2. So we can take this piecewise. 1 times 1 is 1. 1 times minus root 2 is minus root 2. Okay. Minus root 2 times 1 is minus root 2. Then minus root 2 times minus root 2. First, we have two negative numbers. The product of two negative numbers will be a positive number. Then root 2 times root 2 is the same as if you're having 2 raised to power 1 over 2 times 2 raised to power 1 over 2. And by loss of indices, we just take 1, 2, and we say half plus half, and that is 2 raised to power 1. So this is 2, meaning that root 2 times root 2 is nothing but 2. Okay, so let me just clear my rough working. So this here is 2, and I can close the bracket. Then minus times 1 will be minus 1. Minus times minus root 2. The two negative numbers will multiply. So this will be plus root 2. Okay. So here we can just see that what we have is 1 over 2 multiplied by 1 plus 2 here is 3. Okay. Then minus root 2 will give us minus 2 root 2. Okay. Then minus 1 plus root 2. I think our work is getting done now. So if we want to expand this will be half times 3 will be 3 over 2. Half times 2 root 2. These 2 and these 2 will cut. So we have minus root 2. Okay. Then we have here minus 1. Then we have plus root 2. Look at this. Minus root 2 plus root 2. Those will cut out. So we have 3 over 2 minus 1. And we can just say we want to find the LCM, which will be 2. 2 in 2 is 1. 1 times 3 is 3 minus This is 1, which is also 1 over 1. 2 divided by 1 is 2. 2 times 1, that will be 2. So this will be nothing but 3 minus 2 is 1, and we have 2 as the denominator. So all these expressions, all these that we're asked to evaluate, look at how it's just easily simplified for us, and our solution is 1 over 2. Alright. In this theory paper from the WAEC 2020 WAEC exam, here is a question on construction in which we are asked to use a ruler and a pair of compasses only to construct, in the first case, a triangle ABC with line AB to be 7.5 centimeters, line AC to be 13.5 centimeters, and angle ABC to be 120 degrees. And then we should find the locus L1 of point, which is equidistant from A and B, and in the same vein, the locus L2 of point, equidistant from B and C, and then using N, which happens to be the point of intersection of line L1 and L2 as a center, we are to draw a circle to pass through the point A, B, and C. So we are going to be taking our ruler and compasses that they just asked us to use, and we are going to be constructing this triangle and finding the solution as requested. But before we do that, I just want to run through a rough of what we're going to do so that we can have at the back of our mind, this is what the diagram is going to look like. Then we can appropriately plan and also section our construction paper as appropriate. So in this case, we are told that line AB is 7.5, line AC is 13.5, and angle ABC is 120 degrees. As a rule of thumb, it's ideal that we start with the angle so that we can get the inclination of the sides of the triangle as appropriate. So here that we are told that ABC is 120 degrees, that means it is at point B that 120 degrees is going to reflect. So if we have our straight line like this, we can say we want to locate point B. So this will be point B, and it is on point B that we can mark off 120 degrees. So from B, we want to mark off 120 degrees to go to line A. Okay, something like this. But for me, I will just note that here this is going to be 120 degrees. Okay, and then from B to A, that will be 7.5 centimeters. So this is going to be 7.5 centimeters. Okay, and then the other thing we are told to do is to find AC is 13.5 centimeters. AC, so from A to C, and you know C is also going to be on inclination of the line from B. So I can just take another line from A going to, this will be quite longer than 7.5, almost twice the length. So I can stop here to say this is now point C, that is 13.5 centimeters from A. Okay, so this is the triangle that we're asked to construct. It's going to look something like this, and then we have to find the locus L1 of point equidistance from A and B. The locus of point equidistance from A and B is going to be the perpendicular bisector of this line AB. So we are going to have something like this. This is just a rough, okay? So no problem. We are just trying to look at that rough. Okay? We are going to get that. So this will be the line L1. This will be line L1. And in the same vein, we are to look at another perpendicular bisector of B and C. So that will also be something like this, because it will divide the line BC into two equal parts. That is what will define the locus of point equidistant from B and C. So this will be the line L2. This will be line L2. And then the point of intersection, like we are told there, N is the point of intersection. This is N. Then we are to draw a circle to pass through the point A, B, and C. So that means that from N to any of these points, any of these vertex of the triangle, it's going to be the radius of that circle we're asked to draw. So the circle will now look something like this. N as the center, then from here, you have something like this. Okay, and then the circle will just continue and go all around like this. So this is what our diagram is going to look like. Alternatively, you could have said maybe this is B. A could have been inclined to this side, and then in that case C will come to the left, but you still get almost the same. You get the same thing. It's just that now your angle will be flipped to the other side. So this is what we are going to construct, and we are going to take out our construction sheet and use just ruler and compasses to define all of this that we are looking at in this diagram. Now, since we understand what we really want to do, we can go ahead to carry out our construction as appropriate. And the first thing that we want to do is that we want to draw the straight line. So a straight line on the ruler, that's going to be the general reference, and I want to identify the point B. Okay, so I'll just take a particular point, let's say here. That will be my point B. Okay, so I can just label that appropriately and say everything will actually now emanate from that point B, since I've identified that as the point of reference that will be appropriate for me to use. Now, to construct angle 120 degrees at point B, what we do is we bring the compasses to that particular point, okay, and then take an arbitrary radius, not too large. So we just want to take this particular arc, which is going to be angle on a straight line, and that is 180 degrees, but now maintaining the same radius. Okay, we still maintain that same radius. We can take the compasses to one end of the arc that was just drawn, so that's what we are doing here, and then we can mark off the 180 degrees that was just drawn. And here what we are doing is that this particular arc is marking off 60 degrees to this left, okay, and then to the right is 120 degrees, because that arc that we used to mark, if we mark another one here, we are dividing that particular straight line angle into 3 equal parts. Now, one part is taken out. One part of 3 is actually 60 out of 180, so the remaining here is 120. So there we have our 120 degrees. Okay, so that is done. We want to mark off the line AB, and AB we are told should be 7.5 centimeters. So to do that, we just need to bring in the ruler and then mark off 7.5 centimeters on the ruler. So if we go to the starting point of the ruler and we extend that to 7.5, just try as much as possible to be accurate. So this is 7.5. that is what we are going to use to mark off an arc from B, but it will be linking this particular arc that we have drawn. So if you want to take it, it should go from here to here. We can mark off our point on this arc. Okay, so once we've done that, we'll now need to bring in our ruler to appropriately join this particular point B, but it needs to pass through the arc that will mark off as 120 degrees. Okay, and then we can bring in, so then we can mark this off on our construction sheet, and that is how we will be able to actually get our point A as requested. So here this will be point A. Okay, that's point A, and you can see we mark up the 120 degrees, and then we link up with the marked 7.5 centimeters and draw a straight line passing through point B to point A, and then we can label this appropriately that this is 7.5 centimeters, and then we already have our 120 degrees. This is 120 degrees. Okay, then we're also told that the length of side AC is 13.5 centimeters, and in the same way that we just mark off A, we can actually go to the ruler and use the compasses to mark off 13.5 centimeters. That is almost extending to the full length of my compasses, but no problem, you will be able to do that quite easily. And then I will now mark off from point A, because we are going to C from A. and this is what I need to do. So just maintaining that my point of compass is on the right position, I will need to go to point the line from B, this straight line, okay, and then I'll need to mark off that particular arc, and the intercept between that arc and this line is going to give 13.5 centimeters that was measured on the ruler to give us point C. So here you can just mark off that, you can see, and once that is done, you can just appropriately label again after we just join the 2 points A to C. So that's what we are left to do now. I want to join point A to point C. So just bring in your ruler and join those 2 points. And I want to use blue ink again. So yeah, I can just draw a straight line. Alright. So just like that, our triangle is done and dusted, and I can just mark off the point C. So this is point C. Alright. And it is 13.5 centimeters from A. So and just append that as appropriate. This 13.5 centimeters. Then we are now asked to find the locus of points that is equidistant from A and B. The locus of points equidistant from A and B is going to be the perpendicular bisector of the line AB, okay, such that at any point on that particular line, the distance from A to the line and the distance from B to the line, they are going to be equal. So for us to now bisect the line AB, we just take a particular radius, okay, but we need to be consistent with that radius. So just take a particular radius and we are going to use it to mark off. I think I'm okay with the ruler for now. So let's say we mark off this particular point here, and in the same vein we also mark it off here. And then we're going to use the same radius and also take the compass to point B, and then at point B we cross the other arc that we just drew, okay, and then we also go to the one on top and we also mark off that. So what we've just done is that we've been able to successfully look at 2 points that we can join. That's going to give us a line that is the set of locus which is equidistant from A and B. Is going to be the perpendicular bisector of line AB. So in the same way, we can just do the same to point BC, because we are also going to find the locus of points equidistant from line B and C. So that means we are looking for the perpendicular bisector of the line BC. So I'm just using the same arc because I think it will be appropriate. So I'm marking off from C, and then both at the top and at the bottom, and I will use the same radius and go to point B now, and go to point B and also mark off to cross the other arc that I just constructed, and this is exactly what is expected of us. Alright, so having done that, I just need to bring in my ruler to join these two lines. Okay, so this is going to be my line L1 and L2. So I just need to join them with a ruler. So this is line L2. I'm using green for that. Okay, and then I can also go and join the other set of arcs that was gotten initially. So I need to make them a very straight line. Okay, I think that is okay, and then I'll just join these two lines also, and I think that is interesting. That is good. Okay, I'm bringing my label into this diagram. Now look at this. This is this is the line L1, that is the locus of point that is equidistant from A and B. It is the perpendicular bisector of the line AB. So if you take any point, maybe here, the distance from here to A and distance from here to B is going to be the same thing. Okay, so that is the perpendicular bisector of the line AB. And here we have the perpendicular bisector of the line BC, that's L2. So this is L2, the perpendicular bisector of the line BC. And then this is looking very interesting. Finally, we are told that N is the point of intersection of the two loci. So this is point N here. N here is the intersection of the two loci that we have constructed on the triangle. And finally, what we are now asked to do is that using N as a center, so we are to use N here as a center, we are to construct a circle that should pass through A, B, and C. Now, that statement is telling us that N is the center of the circle, and the distance from N to C, which is also going to be the distance from N to B, and also going to be the distance from N to A, is going to be the radius of the circle. So I can just verify that it's going to pass through point C, point B, and point A, and I think looking at this, I'm okay with that. So I can just construct the requested circle. Alright, and you can see this is quite interesting as the circle that we're asked to construct. And just like that, we've been able to answer this question holistically as we are requested to do, and that is the beauty of knowing what you are requested to construct. And you can see from this particular question, we've been able to look at first how to get our point of reference, which in this case we identified as point B, because that's the point at which we are going to take our angle as 120 degrees, and then we mark off the arc that is corresponding to 7.5 centimeters along the line in which 120 is inclined. Then we use our ruler to construct the line AB, and then from A we now mark off from the protractor on the ruler, we mark off 13.5 centimeters and put the needle point on A, and then we mark off the arc of 13.5 centimeters on the line coming from B to get our C. And after constructing the triangle in that way, we went to find the perpendicular bisector of the line AB, which is defining the set of locus of points that is equidistant from A and B. And we did the same thing for the line BC. We constructed a perpendicular bisector to define the set of locus that is equidistant from B and C. And finally, we are able to use the point of intersection of the two loci, that is point N, as the center, and use the length to any of the side of the triangle to construct the circle that we are requested to draw. And with this, we've been able to complete our solution to the question on construction from the WAEC 2020 mathematics theory paper, question number 13. So if you want more videos on construction, just check our playlist. There are quite a few videos that are there that will also help you to build your proficiency in solving questions on construction in mathematics. Here in this question on solving quadratic equations with completing the square method, we are told to use the completing the square method to solve for this equation 4x squared minus 4 multiplied by root 3x plus 3 is equal to 0. So the question before us is, how do we use the completing the square method to solve for this question? And as a guide, this particular list of steps that can help us effectively to solve this question. So we have this as our guide for completing the square method in solving quadratic equation, and looking at what we have noted there, we are going to follow so that you students can have a superb understanding of what we are talking about when we are using completing the square method to solve questions like this. In the first case, we have the equation giving us to be 4x squared minus 4 root 3x plus 3 is equal to 0. If you are to compare this with the general equation ax squared plus bx plus c is equal to 0, you can see that already A, which is the coefficient of x squared, is synonymous to 4. B, which is the coefficient of x, is minus 4 root 3. And C, which is a constant, is 3 in this particular case. So what we are told first and foremost is that if the coefficient of x squared, that is A, if it is not equal to 1, we should divide the quadratic equation by A. So for a particular case here, that means we divide by 4 to say we now have 4x squared over 4 minus 4 root 3 over 4x plus 3 over 4. That's equal to 0. Okay, so here we can see that 4 can cancel 4, and this 4 can also cancel this 4, and we will have our equation now to be x squared minus root 3x plus 3 over 4 is equal to 0. Alright, and then in the second step we are to write the quadratic in the form that the variables will be on the left hand side and the constant on the right hand side. So if you are to do that here, we just have x squared minus root 3x is equal to, when 3 over 4 moves to the right hand side, it becomes minus 3 over 4, and we are done with the second step there. Now this is the key factor we need to really consider when we are working with completing the square method. And what we're asked to do is to add the square of half of the coefficient of x to both sides of the equation. Now for us, that is actually minus root 3. Okay, so what we need to do is we add minus root 3 over 2 all raised to power 2 to both sides of the equation. This is the most critical step that students generally make mistake from, so we should actually take note of it. And if we want to do that, we'll say this is nothing but x squared minus root 3x, okay, plus, now when you have the negative of the number raised to power 2, that negative will actually become a positive because the negative number will multiply itself to take effect of the square, and that will now become positive. So it's the same as saying we have root 3 over 2 all square is equal to C, which is our minus 3 over 4 plus root 3 over 2 all square. Okay, so at this stage, student needs to be very careful because what you now have on the left hand side is nothing but this is the same as x minus root 3 over 2 raised to power 2. This is the expression on the left hand side, and I'm going to show that in a minute. This is equal to minus 3 over 4 plus, now root 3 raised to power 2 is 3, okay, then 2 raised to power 2 is 4. Wow, interestingly. So here on the right hand side we can see that minus 3 over 4 plus 3 over 4 will amount to 0, but I want to show you this because this is originally what you have, and I know this is where students generally make mistake. Originally, if you want to expand this, you will see that this is nothing but x minus root 3 over 2 multiplied by x minus root 3 over 2. Now, if you want to expand that, x times x is x squared, x times minus root 3 over 2 is minus root 3 over 2x, then again, minus root 3 over 2 times x is again another minus root 3 over 2x, then minus root 3 over 2 times minus root 3 over 2. The negative signs will multiply each other to be plus, then we have root 3 over 2 all raised to power 2, and you can see this expression is nothing but x squared. Now we have minus root 3 over 2 minus root 3 over 2. It's as if we are having half of root 3, and half in two places is going to give us a whole, so we can say it's minus root 3x then plus root 3 over 2 all square, which is the same thing that we have here. You can see that. So student, this is what you need to take note of, that when you have your expression like this and you are trying to use the completing the square method, this left hand side will resolve into this particular expression that we have x minus root 3 over 2 all raised to power 2. So that is just a very good point for you to note. I will clear my board now, and now as easy as it gets, what we just have is that we have x minus root 3 over 2 raised to power 2 is equal to 0. Therefore, if you were to find the square root of both sides, you can say x minus root 3 over 2 is equal to 0. So this will give us x to be, when minus root 3 over 2 moves to the right hand side, it becomes root 3 over 2. And notice that this will now be occurring twice. So you can say you want to check if all that we worked is actually the correct thing. Like here we are saying that x is equal to root 3 over 2 twice, meaning we have x minus root 3 over 2 and x minus root 3 over 2 as the two factors like we're coming from here, okay? So of course this is also the expression of this. This is x minus root 3 over 2 raised to power 2 and is reflecting here. So if you want to open this bracket, x times x will give us s square. X times minus root 3 over 2 will give us minus root 3 over 2x. Minus root 3 over 2 times x will give us another minus root 3 over 2x. Then minus times minus here will give us plus. Root 3 over 2 times root 3 over 2. Root 3 multiplying itself will give us 3. Then 2 times 2 will give us 4. This is equal to 0. Now this is the same as s square. Here is as if we are having half. Look at this. We have half of root 3 and another half of root 3, but they are both carrying negative sign. So it's as if we are having two halves that whenever we are combining them together, they will give us a whole. So we have minus root 3x, okay, plus 3 over 4 is equal to 0. We want to reverse back to see if we can get our original equation. And for that, we can multiply both sides by 4. So 4 times the whole of s squared minus root 3x plus 3 over 4 is equal to 4 times 0. What we do to the left hand side, we also do to the right hand side. 4 times x will be 4x squared, okay? 4 times minus root 3x will give us minus 4 root 3x. Then 4 times 3 over 4, the 4's will cancel each other. We have this to be plus 3 is equal to 4 times 0 is 0. And you can see this check is actually confirming to us that x is equal to root 3 over 2 twice is the solution to this problem. The other area in which you could have had the problem is when you have something like, say, maybe originally we could have said that s squared is equal to, maybe we have 3 over 4. Therefore, x would have been square root of 3 over 4. And then this is the case in which it could have been plus or minus root 3 over 2, because root 3 will still be there. Square root of 4 is 2. But what we have here is not that s squared is equal to 3 over 4. You can see the square here was knocked out directly in this particular location, and then our x is root 3 over 2 twice. And that is the solution to this particular question. So that's all we are going to be having in our lecture today. We hope that this will be of benefit, of use to somebody out there. Don't forget to subscribe to our channel. We have a lot of resources that you can use to enhance your academic excellence. And that's our desire, that you go out and be the best. And as you do all this, we know that all will work out together for good. Until next time, God bless you.